Okay. Evening, guys. So, Speaker Freak's first on the stream, as always. Not as always, but often. Speaker Freak is right up in there. Sunday evening repairs, and moved the setup around a little bit. Yeah, so wait, I've got to remember where my camera is now. So yeah, just decided to make the workshop a little bit nicer. As you can see, I've tied up quite a lot in here. If anyone has actually been to visit me in the UK to drop off an amplifier or anything like that, you'll know how horrific my workshop was. It's now not too bad, so there is actually some floor space now, and we still have the rack of amplifiers to do over there. That hasn't moved, but I've kind of cleared up the woofer build kind of area where I've got lots of spare parts and speakers and subwoofers to either repair or to put together. Spare baskets over there, and on top of there more stuff to repair down there. The light bulbs have actually gone, so the lights are supposed to be on, but that's why it's looking pretty dark in here. And then just cleared up a lot of the spare parts over here, just made some space in the workshop, and yeah, I have a new the setup over here is a little bit different now. It's a little bit better. I have two monitors. When I get a VGA to DVI cable, that monitor will hook up, and that will be much easier for me working on the live streams. So very slightly different setup, but it's not that much different. Blew an amp of proper droppers. Who blew? No, I don't think anyone blew an amp of proper droppers. I think we're mostly okay. I've also a slightly new addition. So this is obviously a standard cordless drill, except it's not cordless anymore because I got really pissed off with keep having to charge these damn batteries, and they never last that long anyway. So I literally just hooked it up to my current limited supply. So my power supply up in the top right hand corner of your screen over here, as you can see, I've got it set to 14.4 volts, which is what this is designed to work with, 14.4 volts. And as you can see, the current draw is present as follows, and you can see there that this drill actually incorporates impedance rise. So you know about impedance rise, where the speaker, the subwoofer, creates its own back EMF, which the amplifier sees as resistance. Therefore, the impedance greatly increases in the subwoofer. But the same is true here. If we take a look at this, okay, the if I start spinning the motor, the current draw is very low, 0.9 amps. As soon as I put a load on it, which is what the port does to a cone... Ow, Jesus, a bit of... I turned that on a bit high, a little bit of friction burn there. But yeah, as soon as you put a load on this, the current increases because the motor is under a load, and therefore the back EMF is much lower. Do you have a 3512 motor for sale? Yes, actually I do. I do have a 3500 series motor. It's a supercharged motor as well. So I have a 3500 series supercharged motor that I'm currently not doing anything with. I was going to build up some spare parts, so but I might sell the motor if the right price is right. Notification finally working. Good. Right, so we're going to take this amplifier apart, and so this that we're working on today is a JBL GTO14001. Very standard, very generic, not generic, what's the word? Very common amplifier, but it's one of my favourite amplifiers around this sort of power range. It's a fantastically designed board. It's not your generic cheap crap. It's actually been designed very well by JBL. It's a really solid amplifier, and it does well overrated power when it works. So let's see if we can get this one to work again. Apparently it doesn't work. So let's see what the issue is with this one. How's the van build going? The van is built. I'm just waiting on my DDZ4s to arrive from the States, and then I'll put them on 20k and go from there. But yeah, pretty much the rest of the van is pretty much done, really. It was already built when I bought it, because my guy Henry built it for one of my old customers. Right, so first things that we need to check is is there a direct short across the power terminals? No, there is no direct short across the power terminal, so that's a good start. Next thing that we want to check is, are there any direct shorts across any of the output section FETs? So we're going to take a look at the output section FETs. Now I also have my, oh dear, it's gone green. Why has it gone green? I was going to say we also have my zoom in cam back up and running, but it's decided to go green for some reason, so let's see if we can fix that. The zoom in camera always is a bit of a pain in the ass, so let me just see if I can fix it quickly. Mountain Dew camera, yeah. Okay, there we go. So zoom in camera is now working properly, so yeah, it's what it's supposed to be. There we go. Right, cool. Let's angle it a little bit better. So the angle's a bit funky on it. Let's try. Where's the angle funny on the zoom in cam? Not to worry. That looks pretty clear. I quite like how that looks actually. Looks pretty nice. Cool. So yeah, the output FETs are going to be over on this amplifier. The output FETs are over here. So if we take our multimeter, we need to see if any of the output FETs are shorted before we even think about applying power to this board. It's good so far. Okay, doesn't seem to be any shorted output FETs. So there's no shorted output FETs and there's no shorted power supply FETs. So, so we need to find out then what the hell is actually wrong with this amplifier. Why did the customer send it to us? So let me just go and check my messages here and just remind myself of what the fault with this amplifier was that the guy claimed. Let's see. Okay, it's doing nothing, it doesn't like that, no power. Okay, so according to the customer, this amplifier has no power whatsoever and it shows no signs of life at all. Now usually, more often than not actually, these ones, when the customer says that there is something where the amplifier just straight up doesn't work, often the amplifier is actually fine and what really is happening is the amplifier has fallen out the back of the head unit. So let's see if that's the case this evening then, I wonder. What do we reckon then, guys? Do you reckon the amplifier is actually faulty and it doesn't turn on for some reason? Or do we think that the customer's remote lead or ground cable or something has fallen off and therefore was not sending power to the amplifier correctly? Okay, well, we had a little clip there from the power supply, so it appears that there was some energy stored in the power supply capacitors, so that means that there is a direct connection between these power terminals and the power supply caps. So if there is going to be a fault, it's going to be on the turn-on circuit, which is very rare indeed. So I think this is going to be fine. Very loud static. Oh shit. I'm not sure. Sorry guys, I'm not sure what was happening there. Is that any better? Okay, good. I'm not too sure how much of that you guys heard then, because my microphone was clipping to fuck. But basically, customer said that this amplifier shows no signs of life whatsoever. It's completely dead, no lights, no nothing when he turns it on. I've just checked the inside of the amplifier. Doesn't appear to be any dead components or anything like that. Usually when the customer sends an amplifier in where it shows no signs of life, it's usually actually that the customer's remote cable has fallen out the back of his head unit, or his ground lead has fallen off of the car somewhere, or the power wire, the fuse is blown, something like that. So usually, probably 80 to 90% of the time that's the case. It's very rare for an amplifier's remote turn-on circuit to fail. So But sometimes the terminal can actually snap off of the board, and that's why the amplifier has no signs of life. But we just plugged the power supply in. I haven't turned it on yet, but as we turned the supply in, we saw that there was some back EMF coming from the capacitors, the power supply capacitors, which still had some stored energy in them. So we know that the terminal was connected to the board. So I think this is probably going to work fine. And it was probably the customer's something that fell off. So let's take our oscilloscope probe and let's turn the amp on and see what it's doing. So power supply is here. Oops. Yes. There's one thing I need to do, which I forgot to do in setting up my new workshop, is I haven't actually I haven't put the ground connection to the power supply yet. Yeah, so in order for the scope to read properly, I need to ground the power supply's negative terminal to my mains ground, and that then allows the scope to pick up a signal. So if I just go in there, okay, that should work for the time being. I'll need to sort that out in a minute. I'm just going to update the current amplifier. Yes, you're right, I always forget to do that. Okay, is the scope now working? It's the wrong probe. Okay, scope now works. So yes, you can see we've got our 10.2 volts of DC there waiting to go. Let's fire up and see what happens. There we go, amplifier works fine, blue light, and that is this amplifier finished. There's nothing wrong with it. It powers up just fine. So, a nice easy one for that. Now we can move on to something else. What do you think of the MTX 1501D? I think that's a very good amplifier. I haven't worked on it personally myself. We don't get a lot of MTX over here in the UK. Will you charge the customer for this? So this will cost £15 as a standard diagnostic and check. What I will do off camera a little bit later is I will run a bench test on this and just run it for sort of 15-20 minutes, make sure that it's actually all good. But yeah, most of the time there's that, you know, when the customer said that it doesn't show signs of life at all, and we can clearly see that it does, it's yeah, the amplifier is usually perfect. These are very lovely amplifiers indeed. These are fantastic amplifiers. Really, really nice piece of kit, this. So this can go back in the box, and just for the time being, like I said, I'll do some more tests on that later. But that's that one out of the way. So let me just go and find another amp to work on. I'm just going to check. I've got an amplifier that I want to work on. It's a Pioneer 1200 watt thing, 9601 or something. But I ordered some parts. I just wanted to see whether they actually came or not. Because if they came, I can start looking at this repair. So this will be in half bridge chips if they arrived. It was some 2092 half bridge drive ICs that I ordered, but I can't see them here, so maybe they didn't arrive, or maybe I've lost them in the process. Oh wait, hang on, what's in here? Nope. Maybe I either lost those in the process of clearing my workshop out today, or they haven't arrived. Okay, so let's do something else. Okay, maybe we'll make a start on this Vibe Audio 10K. It's a 10.5K. This is called the Vibe Audio M21K. There is also a version of this amplifier made by DS18, which is the exact same amplifier, just with a different sticker on the front. And I think there's another brand that does the same thing as well. Now this has got an absolute ton of damage. So I'm going to take a zoom in on this one so we can see exactly what's going on with this amplifier. So looks like we have multiple sections of failure in this one. As you can see, this is the power supply section. So already visible inspection, we can see that has smoked the hell up. This is all blackened and scorched around here where the FETs have heated up and exploded. So power supply failure, which usually indicates that there is also an output section failure. And let's just take a look in here. Over this side of the board, you can see, I'm not sure how well the camera makes that out there, but yeah, there's some pretty nasty janky stuff from these FETs where they've all exploded, and this FET on the end here has actually snapped the legs off because it got so hot and exploded. Also in the center of the board, if I zoom in up here, you can see, now this is the power supply drive circuit, and for some reason or another we have some exploded capacitors in there as well, which is always fun. So that means that we could have also lost some of the components on the power supply drive board, which is quite rare, doesn't happen very often, but where you've got a cap that exploded, it actually dumped a crap ton of stuff over here onto this bottom section of the board, you can see. So there might be a couple of transistors over there because they got covered in very conductive electrolyte stuff from the capacitor that will require a repair as well. Fun times. Complicated repair. Lots of things to do. Yeah, there's clean floor in here now. It's very, very strange. Ground Zero X-Max 15. The specifications on that, I mean, yes, it looks like it's got a lot of X-Mech, but it didn't look like it had that much more X-Max than a lot of other woofers I know. It's got too much surround. They could have incorporated more cone area in there rather than going for such an oversized surround just for looks. That's all it is. Do you have a video about your benchmark procedure and setup? Yeah, I've got some old videos where I do a bench test at the end of the amplifier repair, so you can see that process. The workbench will be in a different place, and the setup will probably be a bit more basic than it is now. But yeah, the same idea is there. I'm just getting a mosquito down thing. When are you going to modify an amp to its limits? I need some spare time to do that, which is not something I've had a lot of at the moment. So that video will come. I apologise for the delay on that video. The amplifier that I was actually going to do it to, I ended up selling because a guy was desperate for one of them. So I thought, okay, let's sell this to this guy. So when I get an amplifier that belongs to myself, I will be able to do that that video. I actually will be doing an upgrade shortly. Someone is sending me a what the fuck? Someone's sending me a JBL 14 001, the same as this. Someone's sending me another one of those, which has actually blown because the guy has been running it at 1 ohm. Now that is a 2 ohm stable amplifier. And because he wants to continue running it at 1 ohm, he's asked me if it's possible to do any changes, make any upgrades to the amplifier circuit to make it stable to run at 1 ohm. So I'm going to give that a go, and I'll do that on live stream for you guys. When I get that amplifier in for repair, I'll obviously make the repairs, but I'll also do absolutely as much as I can to upgrade the amplifier to make it more stable at 1 ohm. The sort of standard things that I would do in that case would be to upgrade obviously the output FETs to something that can handle a little bit more current and a little bit more heat. Something with a lower RDS so it doesn't heat up as much, and also something that doesn't increase its resistance, its on resistance, as temperature increases quite so much. Then we need to possibly modify the drive circuit so that it drives these new more powerful FETs. I think the 14001 that uses a IR2010S drive IC, which is actually quite a powerful drive IC. So those drive ICs, they run a 90 N20D FETs, which are massively powerful in the band amplifier, so that'll have no trouble. Okay, so yeah, we shouldn't have to touch the output drive circuit at all in the JBL, which will be quite nice. But obviously, if we upgrade the output section, if we do the upgrades on the output section, and that's demanding more current, then we also should make some upgrades to the power supply section to compensate for the additional current demand from the output section. So yeah, that'll be interesting. Again, that'll probably be just changing the FETs. We might have to change the power supply section drivers, because I think the power supply is only driven by a tiny little A1023 and C1027 transistor NPN and PNP pair, so we'll probably have to upgrade that a little bit. And also we may have to upgrade the rectifiers after the power supply transformers, because there will be more current demanded through them as well. But I don't think it will be that difficult. The JBL GTO14001 is already stable at 1.33 ohms. So all we got to do is we just got to make it that 0.3 of an ohm stable, which isn't going to be hard to do, I don't think. I think we should have pretty good success with that. And by using the JBL GTO14001 at 1 ohm, the amplifier will feel and perform probably like a 2.5K amplifier, which will be really pretty cool. The only downside is that the amplifier comes with 4-gauge power terminal inputs, which isn't really good enough for a 2.5K style amplifier at 1 ohm. So if you're going to be running that amplifier at 1 ohm, then I'd recommend getting some reducers for your 0-gauge to go into that amplifier, just to reduce the amount of voltage drop across the cable from that insane current demand that the amplifier will ask for. Microphone still working? Yes, it is. Good. So yeah, these new Vibe amplifiers, they're made at Xenon factory in Korea, which is a reputable build house. It's a very good place where they make very good amplifiers, including mine Lawrence's range of LW audio amplifiers. Which is the LW audio and the Ampere audio and the FSD amplifiers and Twisted Sound amplifiers are all exactly the same amp, and they're all made in Xenon factory, and they're all bloody good half-bridge amplifiers. However, this is a full-bridge amplifier made at the same factory, which unfortunately seems to have some reliability issues. It's quite a new circuit design from Xenon, so I think that they have some bugs to iron out here, and I have seen quite a few of these, considering how little there are of these things floating around at the moment in this country. And now I have gone ahead and unscrewed way too many screws that I need to, but never mind. That's fine, that's always what happens. You always undo more screws than you need. I usually get a pretty good knack of knowing exactly which bolts to undo to make these things easiest to slide out, but this evening I've been talking my arse off, and yeah, we've made a slightly less efficient work for ourselves here. Right. So unclip the fans from the board here, and so that's that side done. Now we just have to bring all the FETs off of the heatsink and slide the thing out. So at the moment, even though we've removed all the bolts from the outside, there's still a bunch of screws going down the center of the board, which we need to remove. As you see, this drill actually works very well on 10.2 volts. I don't need the full 14.4 volts really. That's just excessive if I was using this as a drill. But for a screwdriver, anywhere between probably 9 and 14 volts would be absolutely fine. Okay, is that all of them? I think that might be all of them. Yep. Xenon used to make Sundown, but I believe they've changed their build house now. It's somewhere else. It's still in Korea, but it's the other build. There's two main build houses in Korea, I think, and Sundown are at the other one at the moment. They did used to be at Xenon, yeah. Does a full bridge amp have advantages over a half bridge? The size, really. The size of the physical size of the amplifier can be a lot smaller than a half bridge. And you can get away with using slightly less components. And I think, yes. Yeah, you can get away with less components. So yeah, with a full bridge, obviously, on the amplifier's output terminals, both the positive speaker output terminal and the negative speaker output terminal both have audio signal on them. They're just out of phase with each other. So let's say that the positive speaker terminal has a 50 volt sine wave on it. Well, then that would be in a normal half bridge amplifier. That 50 volts is just 50 volt to ground. That's what the speaker sees. Whereas in a full bridge amplifier, the positive speaker terminal has 50 volts AC on it, and the negative speaker terminal has 50 volts AC in opposite phase. So therefore, the speaker sees double that voltage. It sees the potential difference between the two speaker terminals then becomes 100 volts. So you basically get to double your voltage on the speaker terminals without needing a rail voltage that is so high. So you can create, you can just have a much lower rail voltage, but by driving it in full bridge, the potential to the speaker is twice what the rail voltage is. Okay, is this going to slide out now? Yes, it should. Yeah, here we go. Any parts that I've missed? No, maybe? Okay, so I'll tell you something else as well that makes these amplifiers an absolute pain in the arse to work on. Okay. Ooh, bits of FET flying everywhere. What's up, David Santos, my man? How's it going? Good evening. Okay, so the thing about these amplifiers that makes them a massive pain in the arse to work on is the fact that the MOSFETs, they all have, so usually the FETs have like a pad on the back of the FET which insulates the back of the FET, which is live with the drain, to the heatsink, which you don't want obviously. But these FETs are soldered to these special thermal transfer pads that are electrically insulated. So not only do we have to remove all the FETs and put all new FETs in, but we have to take these pads off, desolder every single one of these, and resolder every single one of these to the new FETs that we're putting on the board. So it takes flipping ages compared to a normal amplifier that doesn't have this mounting method. What I worked out is a really nice quick way to do that, or to desolder them at least anyway, is actually go in the kitchen, cook up a big ass frying pan, put the FETs in a very small amount of oil just for a bit of thermal transfer around, very small amount of oil, and then you put the FETs in with the things on the back with the FETs facing upwards. Cook it up on the frying pan for about 2 minutes. It only takes with a high heat, and then you'll notice that actually the solder melts really quickly. So you can just take your long nose pliers and you can just pick the FETs off of the backs of these things in the frying pan, put them to one side, and then you've just got a frying pan full of these insulator backs. So then cool them off, obviously, in the water, clean them up, refresh the solder on them, and then when it comes to soldering new FETs on, you can possibly do that in a frying pan again. The only problem I found with that is it's quite difficult to sort of, I don't know, you can't really get a grip on them. It's a bit of a pain in the ass. The better way I found to solder them on is to actually just do them one by one on the workbench. So you just put the FET face down, put the thing on the back, a new fresh solder pad, except blah blah blah, new solder on there, and you just get your iron with a big tip on it with a lot of thermal mass. You hold it on the back of the pad and it just melts the solder eventually. It takes about a minute and a half, 2 minutes per FET, so it takes fucking ages. But if anyone else has got any better suggestions on that, then let me know. You like Fortnite? No, I don't actually play any computer games whatsoever, other than I'm quite interested in sim racing, but no, I don't play any FPS games or anything like that. I don't have a computer that can do it for a start. My computer is still a LGA 775, so there's no chance of me playing any game that was released in the last 10 years or so. No chance. So, okay, well, the first thing to do then is we're going to start. This amplifier has a massively failed power supply, because we can clearly see that on the board here. The power supply is cooked up to fuck. As we can see, everything is dead. Everything is dead. Looks nasty. So, yeah, there's not a chance in hell that any of these power supply FETs survived. So rather than spending ages, we're just probably going to go ahead and just snap all of these off. Rather than desoldering them one by one. So we need to get rid of the direct shorts across the power terminals, because at the moment, with all these bad FETs in, there'll be a direct short circuit between the power supply inputs, which is going to be like this. It's going to go beep, beep. See that? Absolute direct short across the power terminals. So there's no point trying to put any power into this amplifier whatsoever, because it's just presenting a short circuit. So let's go ahead and get rid of these. Now, in clearing up my workshop, I seem to have misplaced my cutters, which is a bit annoying. So I'm probably just going to have to wiggle each one of these off manually like this for a minute. Good evening, Seth. How's it going, buddy? Do you notice a slightly different setup this evening? We're in a slightly different orientation now. I've made my workshop a lot cleaner than it and a lot more tidy. Better layout, I think. This is a much more comfortable position for me to be in, and I've got things at a better eye level. I've got 2 screens in here now until I get my larger TV, and I've also got a space for a nice sound system in here as well that I can put in to listen to some music when I'm not live streaming, so that should be pretty nice. Yeah, I've got this my parts are now right to the side of me, and I can really look inside the drawers there to find the correct part. I have done a 775 to 771 mod. That's exactly what I've done. I am running an Xeon processor. I'm running a X5470, I think it is, and it's overclocked to 4.5 gigahertz. So it is an old system, but it is still pretty damn fast. Like, I'm able to do this live stream on that system. So I've got 7 cameras hooked up, 2 video capture cards. Yeah, we're rendering in 1080p at 900 kbps. No, sorry, 9000 kbps, which I could probably go higher on if I wanted to. What else? Yeah, it's got 8 gigabytes of RAM, I think, which is probably the maximum that you can really find in these DDR2. 8 gigabytes worth of DDR2 RAM. So there's a proper old school 775 board. Yeah, it's a Gigabyte EP45 UD3P. U3D, what is it? D3P, I think it is. So it's a proper old school board. Good evening to Marvin. Yeah, thank you very much, buddy. I love your viewership. You love my videos? I love your viewership. Now we've got to be careful here because I'm going along mindlessly snapping all these off, not to snap off the goddamn rectifier. So the rectifiers thankfully are labelled quite clearly on this board as so. You can just about see it with the all the soot, so if I try and clean that off a little bit, I've just made it worse. I've got to work out where this camera is actually pointing. Where is this? Right, that's my finger. Right, it's there. Yeah, so you can see there. This one is a FET and this one is a rectifier diode because we've got the diode markings there on the board. So I need to not snap this one off. That needs to stay nice and tidy. I need to snap this one off instead. Why don't you get a solder bath? Those are quite useful and might work for desoldering the MOSFET insulators. What the bloody hell is a solder bath? I've never heard of that before. That sounds pretty interesting. Is that must be some kind of shallow tray that you fill with solder and perhaps, and then it heats up and you can desolder multiple components from that. Or a solder bath is probably also used to put new solder to tin pads on a fresh circuit board. So let's say you get a completely clean fresh circuit board printed, rather than having to go around and tin every single pad of the SMD pads locations on that board, you just drop it in a solder bath and all the pads get tinned and the solder just doesn't stick to any of the board itself. Is that what it is for? I have no idea. I'm just completely guessing right now that might be what it's for. Barry says, hi, I see... why am I still holding this amplifier up to the zoom-in camera? That's stupid, my hand's getting sore. Hi, I see last weekend a lot of your videos. I want to try and repair a Denon home theatre receiver. 2 channels. It was blown because it was running under minimum resistance of 6 ohms. It was running at 2.5. That sounds like something that I would have done back in the day. Sadly, I don't do a lot of home audio mains powered equipment repairs, and the ones that I have attempted haven't actually turned out pretty well. So unfortunately, although I do repair amplifiers, car amplifiers are very different in your repair procedure, and it doesn't really transpire to home audio, I've found yet. So I've not been too successful with home and PA and house amplifiers just yet. So I'm possibly not the best person to ask. I would quite like to take that on at some point, but in order to get better at home audio repairs, I need to float my oscilloscope's ground earth so that it's not on the same line as my mains, and the neutral isn't on the same line as my mains. Because that means when my scope is obviously connected to the same source as the amplifier, in that sense, I can't actually probe anything on the board because it doesn't show up. I just get a bunch of 50 Hz noise, or sometimes it trips my RCD. So sadly, that's not possible at the moment. Don't snap the rectifier. Giant, hey Sam. Hey Giant, how's it going? Good evening. We're in the middle of a repair as well, somewhere over there in the workshop. We're also in the middle of a repair for Giant in the live chat. We're doing a Steg 5K, which is a 2.5K board, and it has a really strange issue where it appears to work beautifully when the amplifier is not loaded by a speaker. There goes to clipping point, wave looks great, drive looks great, but as soon as you put a load on the speaker terminals, it loses the top half of the audio wave. It flattens off like really early, like about 9 volts of output, and it draws a lot of current, and the high side FETs get very, very hot. So that has some weird issues, and we're trying to tie down what exactly the issue is on that amplifier. But sadly, when the drive wave glitches out and causes that problem, the drive wave is showing the glitch everywhere because it's in the feedback loop. So you can't really narrow it down to one component just by reading the drive waves. You have to go by just thought process of, right, what would be causing that? And we've already tried changing the PWM generation chip, which is a HEF 4060. That didn't help. We tried changing a couple of amplifier chips, little op amps on the board. That didn't help. We tried fitting different output FETs that were a higher voltage rating and easier to drive. That didn't help. So the next thing I want to try and do is change the actual drive ICs that are on the board, because I noticed that they are slightly different to the ones which I think the amplifier probably came with by one number. I think it's like a 4422 is the amplifier came with, and that one's got 4421s in it. I haven't googled the difference of those yet, so that could be what's causing the issue. If that doesn't fix it, then we're going to try a brand new driver board, which I have sourced from Steg themselves, which costs 120 goddamn euros. If that doesn't fix it, then I have no flipping clue. There's a massive headache, that board, right? This has got loads of fat, stanky ass parts on it. So I have removed all of the power supply FETs. Now, hopefully that means that it has removed the direct short circuit across the power terminals of this amplifier. So I need to get this camera angle a little bit better here. So I do need to go over that way slightly. Yeah, that's a bit better. So yeah, hopefully that's removed the short circuit on the power terminals. If it hasn't, then we have a drive circuit failure. Okay, yes, so you can see now the multimeter is charging, so therefore we no longer have a short circuit on the main power supply rail. So, but if you were with me earlier, we did notice that in the drive circuit there were some pretty nasty looking stuff. We have some blown off capacitors here, and we need to clean all this stuff up before we apply power to the board, because you see all this residue, all this kind of fluffy stuff that's come from inside of the capacitor, that is all conductive, and we need to take that all out, get that cleaned up nicely before we think about even putting some power to the board. So I'm going to have to go ahead and remove and desolder. Actually, I could probably just snap these off for the time being. This capacitor, this was probably some kind of smoothing capacitor for the drive, the power supply drive, something like that, or perhaps it was a timing capacitor for a relay, for the switch on relay. So let's just get rid of that, and we can work out what that does afterwards. We can either work out what it does by powering the board up and seeing what doesn't work, seeing what fails to activate, perhaps if it's the relay, or we can see if the drive wave looks a little bit dirty, then that capacitor was possibly doing some smoothing. But where this capacitor has quite clearly chucked its guts over all these components, you see there's a small diode here, D14, that could, I think you can't see it, there's something in the way of it on the camera. D14 could actually be shorted out because it had some of this fluff either side of it, so it could have got the voltage from the other side. And then we've also got Q32 here, which also got covered in this crud, so this could also be damaged. Pretty much anything around an area where this electrolyte stuff has exploded from a cap often is not good. If anybody remembers, a while ago I did a repair live stream on a JBL GTO14004, which is the 4-channel, and that had a similar situation where in the power supply drive circuit we had a capacitor explode, and it exploded over the driver board, but much more of the driver board. And I don't know if you remember, but pretty much every single component on that driver board was dead. Resistors were dead, diodes were dead, ICs were dead, transistors, everything, pretty much anything that this stuff touched had shorted out. So I'm hoping that we don't have a similar situation here and we got lucky, but I am prepared for the worst here. I am prepared for the worst. So I've got the most of that stuff off, but it's not all gone. So what we need to do next is we need to take an old toothbrush, like so. And we take some 99%, it's very important that you get this as pure as possible, 99% isopropyl alcohol. Spray that the hell up in here, all on the affected area, get it nice and soaked up. And then we're going to take our toothbrush and we're going to give it a good old clean. Try and get all of that crud out of there. And you don't have to be that gentle, you know, like these pins for the driver board, etc., they should be soldered incredibly sturdily, and so if by just doing this the driver board comes off, then they were not strong enough in the first place. So yeah, let's give that a proper clean off. I shouldn't have to remove the driver board. It looks like this is cleaning up pretty decently. I would quite like a toothbrush, but that had the bristles on this end as well, so I could just go down inside the board like this and clean off, but that doesn't seem to exist. What I could do is I could actually snap the head off of this toothbrush like this and then just glue it to the top. So I'd have like a mini broom. That would be really useful actually, a little mini broom for the amplifier. because it's not that easy actually getting all up in here, especially around this small transistor, this Q32. Not that easy getting up around there, but the bristles are pulling up the majority of that stuff. So I'm going to go ahead and take a guess and say that the drive transistors have also failed. We've got actually, yeah, a very burnt, oh god damn, yeah, look, that drive transistor there. This wire is in the way for you to see. There we go. So this drive transistor here has a nice big bulge on it and it's cracked down the middle, so that is quite clearly dead. So yeah, we need to remove those before we put some power into the board as well. So I'm going to go ahead and change all these drive transistors. Now we need to get them in the right locations because these will probably be using NPN and PNP transistors. So we've got a C2814, C2814, and the PNPs will probably be A something. And it's always the PNPs that die. Yes, A1715. Okay, so the PNPs are on the outside here and the NPNs are in the middle. So just remember that, guys. Because I'm going to snap these off the board just now. So the PNPs are on the outside and the NPNs are in the middle. This one has literally just disintegrated. This got really, really hot. This got really, really hot. Yes, that is correct. Just having a quick look at the live chat. Isolation transformer is exactly what I need to start doing home stuff properly. Bass Blaster says, home audio is always easy. If it's under £1,000, new is likely to be standard class AB. That's pretty cool. See, I'm actually better at class D amplifier repair than I am class AB. There's still a lot about class AB amplifier that I don't understand and that I'm not that good at yet. So that's what makes home audio even more challenging for me, is that class AB I'm much less familiar with, and also the fact that it is mains powered and I can't quite read it on my scope yet makes it even more challenging. And also I hate the fact that with mains power stuff, you make a repair and you don't get a chance if the repair is not correct, if you've missed something or if you put the wrong part in or something, the second that you apply power to that amplifier, it's back up in smoke again because there's no current limiting really. Or I could incorporate some current limiting on the main supply, but with such high voltage going into the amplifier, it's very difficult to kind of make a safe limit really to the sort of power that's going into that thing. I did have an idea, but I will share that if and when I get around to doing it. Okay, so yes, lots of burnt board in here from the drive transistors. So we'll scratch off some of this black carbonized top coating to the board, because that can be conductive, and hopefully it hasn't burnt the board so bad. In some of these cases I've actually had to cut sections of the board away. Oh dear, looks like I might have to do that on this one as well. This board is actually starting to come away. It looks like it's got that hot that actually the board itself is weakened, and it's yeah, look, that's probably going to end up being a hole, and I might need to make it a hole if this is conductive. Okay, I've got another video which is called Worst Power Supply Drive Section Repair, and it's a similar but much worse scenario to what we've got here. I did have to make a lot of holes in the board because it was all conductive, but I think I'm going to test it with my multimeter. Hopefully this carbonization isn't conductive. These blue boards are much better quality than the yellowy or orangey boards from China, and those ones always go super conductive when they carbonize. but from memory these ones aren't too bad. So I'm going to take my multimeter and we're going to make it super duper sensitive. We're going to put it onto the highest ohm setting, which is 2 mega ohms, which means that any tiny bit of conductivity on the board will show up on the multimeter. So I'm going to go ahead and dig my probes into this kind of carbonized area of the board. I'm not going to touch any of the pads or traces. I just want to see if the board itself is conducting. Ah shit, yes it is. On my multimeter here you can see just about in the corner we've got a reading of 0.7, 0.805, so there is actually current passing through the PCB itself, which is a massive ball ache. That means that we're probably going to have to scratch all this stuff away, and probably going to end up having to make a hole in this board to get rid of that carbonized board. Now this PCB material is very strong when it's not carbonized like this. So if we take a section of the board that's not been carbonized, like I don't know, here for example, this is absolutely solid. Like there's no way, no matter how much you scratched at this with a small screwdriver like this, there's no chance in hell that you would ever do what it's doing here with this part of the board. Let's see if I can spin this around so you can see that a little bit better. There we go. It's a bit better on the camera. So I've got a feeling that this center pad 2, which is the number 2 of the PNP, I think that that's probably going to have to go. And we're probably going to just have to make a hole in there and have to bodge the. Let's see if that's now conductive anymore. Okay, so it might still be a little bit conductive between these pads, but there is a kind of limit. So what I'll do is I will leave that as is to prevent making any more physical damage to the board, try and get rid of the conductivity. We'll fit the drivers, and I'll probe the drivers very carefully, and if this 2 NPN and PNP pair has additional noise, or if the drive wave looks any different, even the slightest bit different to the rest of them, then I will have to go ahead and probably drill that bit out to get rid of the conductivity there. Okay, next thing I'm going to do is all these parts that got covered in their capacitor guts, I'm going to check those on the multimeter. We're going to put the multimeter back into diode beep setting, so we've got continuity setting. I'm going to go ahead and check some of these semiconductor parts, like this diode D14 over here. And what we're looking for is probably going to be a direct short if the thing is faulty. If the thing works, we'll have infinite continuity one way and flip the probes the other way, and we'll have a number. In this case, we have 553 on the multimeter one way and infinite on the other way, so that's probably fine. Now, we've got this small transistor here, Q32, which still has a little bit of crap on one of its legs. So let's try and get rid of that. Now this transistor got hit pretty bad with the electrolyte stuff, so let's flip the board over. Actually, in this case it can be easier to probe it from down the side. We're going to probe. Oh yes, you can see on the back of the board here, you can see where those drivers got very hot, and it's burned right through to the bottom of the board there. That's serious heat to do that. That's serious heat. So the small transistor, I think was, where was it? Was it this one here? So we're looking again for direct short on the multimeter if the thing is faulty. It could be slightly leaking and not showing a direct short, but we're not going to replace it just yet. If it's not showing a direct short, then we're going to just go ahead and take a chance on that one. Okay, the other stuff on the board here is mainly resistors that got hit by the stuff. So resistors are less likely to fail if they get hit by electrolytes like this, especially in this section of the board where it's generally very low voltage stuff, like for power supply drive signals, or the relays turn on signal, etc. It's all going to be around a sort of 5 to maximum of 12 volts. So it shouldn't be too much of a problem, not like it would be in the output section. I'm going to go ahead and check this transistor on the driver board, which was covered in fluff from the capacitor. That again, that seems okay. I think we may have got lucky here, guys. A bunch of capacitors that were somewhat covered seem to be okay. This transistor, which I believe does deal with the relay turn on, seems to be okay. Okay, so we may have got lucky there, and the capacitors, electrolytes, didn't actually cause any further damage there. So, I think then we have removed all of the obviously shorted out components on this board. So what I'm going to do now is we're going to check the integrity of the TL494 chip, which is on the driver board, and that's the thing that generates the pulse width modulated signal for the power supply to function. Now, usually that chip's absolutely fine, but given the state of this amplifier, we're going to check it first of all before we put any new drive transistors in. So to check the integrity of the 494, I'm going to go ahead and apply some power to the amplifier. We only need very, very little current in this case, because we are not powering any big transistors, we're not powering up any capacitors, we are literally just powering a teeny tiny IC. So let's plug our power leads temporarily in there. I'm not even going to bother screwing them in. I'm just going to shove them in so that they hold in the power terminals, because it's so little current I can't be bothered. Maybe I will if it keeps falling out like this. Usually these stay in if you give them these wires they get jammed in the side of these big screws. There we go. That's fine. So let's go ahead and apply some power. Turn the current down first on here, just nice and low. Okay, there we go. So we've got 10.1 volts there, and the power supply capacitors all charged up big time then. There was a big ka-chunk from the supply. So let's take our scope cam back a bit, get that back in view. There we go. Right, so what we're looking for is we're looking for a good drive wave on all of the pins or the pads for the drive circuit here. I'm just going to gently move the amplifier into slightly better view here without pulling the wires out the side. So just check first of all we've got 12 volts on the MOSFETs. Yes, we do, and there shouldn't be anything on the gates and nothing on the drain. Nothing on the gates, nothing on the drain. That's good. Okay, good. So there's nothing leaking on the MOSFET locations. That's good. So if we take a look at the drivers over here, we should have, yes, we've got 12 volts. And now the NPNs and PNPs, they should all have 12 volts on their pin number 2s. Now this one obviously isn't going to have 12 volts on pin number 2 because the pad which transferred 12 volts was in the middle of the board here, and that's got obliterated. So we need to make a jumper wire to connect 12 volts from this leg to this leg. We'll do that on the back of the board later. The same case goes for this pad over here. If I move this capacitor out of the way, you'll be able to see. Pin number 2 here has 12 volts on it, which you can see on the scope that jumps up, and this pad should also have 12 volts, but it doesn't because obviously there was excessive current drawn, and the trace here has actually fused. It's actually cracked and broken the connection because due to the high current. So we're only going to need to go ahead and do the same as what we did over here. We're going to have to jump over the connection from pin 2 here to pin 2 on here. Now the drive wave from the TL494 from memory is always on pin number 3 of these drivers. So let's go ahead and apply our remote signal, and we should hopefully see some nice looking drive waves on pin number 3 of these. Okay, so I just heard the relay click in, And yes, this is backwards. So the drive wave is on pin number 3, but I'm looking at it backwards here. So there we go. Let's just zoom in a little bit on my scope so we can see that sexy looking drive wave a little better. So we have a nice, pretty healthy looking drive wave there on this couple of pads here. So this is a 6.0, yeah, about a 6 volt RMS drive wave to the power supply gates. What's going to go into the drivers. So let's just check all of these locations, make sure it looks exactly the same. This is the leaky location, so if we probe the 3rd pad, we shouldn't have anything, and we also shouldn't have any of that drive wave riding on to the 12 volt source there. No, good, good, good. They're looking pretty sexy. Go over to the other side now and take a quick peek over here. Yep, that looks pretty good. Once again, we're missing the 12 volts over here, so that's probably fused off. We're missing the 12 volts on pin number 2 over here. Okay, looking good, looking good. Nice big square wave. Good. Okay, so the TL494 is in fact intact and appears to be fine. The relay clicked into operation, which means that the relay circuit is working fine, so that's good. So I would say that we got lucky in this case, and the capacitor didn't actually kill anything else. And that capacitor is probably just some kind of smoothing for the drive waves. So we're going to have to go ahead and replace that. Now obviously the capacitor exploded in such a dramatic way that we have no idea what value it was without a schematic, but luckily I have an identical one of these amplifiers in a fully functional order because I fixed it, sitting over there. So I'll go ahead and have a look at what the value of that cap was a little bit later, and then we'll go ahead and replace that. Good evening to DJ H. Nice of you to join us here. Let's turn the supplies off, let these caps discharge a little bit through the supply. What we've got going on in the live chat. Good video as always, thank you. I have a noob question. What is used for power supply deep cycle batteries? For bench testing my amplifiers, I use Dell server power supplies, 2,100 watts, 175 amps per supply, so 350 total because I use 2. I could do with some more though, because I can at the moment I can bench test up to about 6,000 watts RMS. Anything more than that turns the supplies off or kills them, as I did once. I tried to bench test a Lanzar, it was a Lanzar Opti 6K at 0.5 ohms, and it killed one of my Dell server supplies, but I managed to fix it using some IRFB 3077s. Out of all your amp repairs, how much percentage would you estimate blow by human error? If you count vibration damage as human error, then probably a good 80% of amplifiers die by human error. 10% are probably random error, where no idea what caused it, FET just decided to short for some reason. And the other 10% is like a bad design thing from the manufacturer, or just parts wearing out of their own accord. Checking on my Tarams AK, and I noticed some of the connections around the main transformer were missing some solder and getting hot. Do you think that could cause bad output? Yeah, if you've got a connection on the board that's getting hot, that is a bad sign. That is, yeah, because obviously anywhere that you've got heat being generated, that means you've got a high resistance. So if you've got a high resistance area where current needs to pass, then that's going to cause issues. It probably won't cause output issues unless there is significant voltage drop across that bad connection that it's causing the output section to not have the required rail voltage when the bass kicks in to work properly, which it might do. So I would say go ahead and cook that shit up with some fresh ass solder, get that a nice strong connection, and test it again. I have my amp mounted to my enclosure for a long time now. I've never broken an amp. Is that just bad glue on the board then? I can imagine the box could flex though. Yeah, boxes do flex, and like one person's box will flex differently at a different frequency and in a different intensity to another person. So some people get away with running their amplifiers on their subwoofer box for years and never encounter a problem. And also maybe they have purchased a much higher quality, better built amplifier than some other guys. So if your amp's going to be damaged by being mounted to the box, then generally the amplifier is not manufactured as well. It's the build quality is not as good, and possibly also the box is just happening to resonate at a specific frequency that happens to resonate the legs or the transformers or whatever else is going to be shorted out or rubbed or snapped off as a result of vibration. But yeah, you can be lucky in the sense that your amplifier is built well and also your box isn't resonating or vibrating at a frequency which is going to kill parts in the amplifier. So it's all a guessing game and it's pot luck. And it's not a game I would like to play, so. Thank you to MPH, that's very kind of you, my friend. Alright, let's crack on with this. So we have, we know that the TL494 is good. We have a good, sexy TL494 because it's generating some pretty nice drive waves. So let's go ahead and fit some new drivers to this board, and then we can see what actually that capacitor was doing. That smoked up, and once we fitted some new drivers, we can fit a couple of power supply FETs and see what the issue with the output section is. So let's go ahead and take our soldering equipment and get rid of these pins. And I'm going to put new drivers in. We're going to slightly upgrade the drivers as well. We're going to put some 2SB 772s as the PNPs. The PNP transistor is the most important one because it is the transistor which turns the FET off. So in the drive circuit, you obviously have the TL494, which is emitting the square wave, which is telling the FETs to go on and now turn off, and now turn on and now turn off, and now turn on and off. And the FET needs to be turned on and off by that signal very quickly and precisely, because if it's not, then it's going to get hot, because it's going to be left turned on for too long after the off signal has been applied, and it's going to get some shit from the other outer phase bank of FETs. They need to work in push-pull very suddenly and sharply. So in order to drive a bank of FETs strongly, the TL494 has a very weak output, so it needs to be buffered by something. So you have a pair of transistors, a PNP and an NPN. The PNP transistor is responsible for taking the signal, giving it some more grunt, giving it some more current handling behind it, some more power, so it can drive the FET with a good strength, turn it on and hold the charge. And then the PNP is responsible for taking that charge and grounding it. When as soon as the signal disappears, as soon as the TL494 goes to off, then the PNP goes whoop, I'll take all of that charge from that MOSFET gate and I will dump that to ground, and that MOSFET is going to turn off instantly, because without that PNP, the gate of the MOSFET is actually capacitive, so it actually holds a charge of its own. When you drive the gate and you let go of the drive, you turn the drive off, then the gate will still hold its own charge, and that therefore there'll be a delay in the FET turning off. So that's why you have the PNP to ground that straight away, and then the FET turns off as quickly as possible. Hopefully that made sense. I also seem to have lost my good tweezers in the workshop move around, so I don't think I'm going to be able to use these. I'm not. These are not actually. They're not even lined up. These are pretty shitty tweezers. Where the hell are my decent tweezers at? You know when you clean up, you tidy up, and you move everything around, and then you can never find anything anymore. That's what's going on here. Ah, right, there we go. That lined them up a bit better now, so that seems to work. Now, I probably should actually toast these up with some fresh solder. I was going to originally avoid doing that because the board is a little bit damaged, carbonized from the heat, so I didn't want to apply any excess heat where I didn't need to, but I think we'll be alright. How is the zoom-in cam looking, guys? Oh, by the way, if any of you have been watching my live stream for a while now, and you remember the old zoom-in camera location, it used to have issues with interlacing. So when you moved quickly on the camera, it had all the lines on the screen. But look, I fixed it. They have no interlacing problems anymore. Hopefully, oh, damn, you can see the state of my nails actually, as they're not too keen on that camera angle with my fingers there. But that's what the workshop does to you, unfortunately. But yeah, hopefully the zoom-in camera looks a lot better now that the interlacing issue is sorted. Some nice ASMR type sounds probably going on here. I don't know how well the mic picks this up. You've got the kind of faint drone of the fume extractor pump in the background. You've got my computer's fans going absolutely nuts because the CPU is working its arse off streaming this overclocked Xeon LGA771 chip. And you got these intimate kind of tweezer sounds on the board here. Okay, this pin is obviously thicker on the other side, so we're going to have to pull that one from the other side. Looks like Modbox has a good question. I'll read that in 1 second. I'll just get rid of this pin. Okay, so what does Modbox say? Modbox says, oh wait, where? Here we go. Working on a TS 3.5K. There was a broken ground trace fixed, no output terminals. Wait, trace fixed, no output terminals. Don't produce DC volts. Here's my question. Okay, I'm not sure what you mean by that, but it has 4 A1023s and 4 C1027s. Can I use 140s and 139s in place of those and stock P1405 12 FETs with an amp remote applied? Should I get voltage on the gate pads? I read 0 no FETs. So in Modbox, yes, you can replace the A1023s and the C1027s with 140s and 139s. The 139 is obviously replacing the C1027 and the 140 is obviously replacing the A1023. Yes, you can do that. And yes, you can put 1405s in there if that's what it had as standard, that's fine. Without any of the FETs in place, you should see the drive wave on the gate of the FET pads. So you obviously need a scope to read that. I think that might transpire to around 3 or 4 volts of if you're using a multimeter, but you need to check the shape of the wave first. Jesse says, I'm watching the stream on a 40-inch TV and yes, the zoom-in looks awesome. Good, I'm glad. The zoom-in camera is actually my only decent quality camera. All the rest of the cameras, so this far-out camera, the top board camera here, the scope camera, and the head camera, which is currently sitting over here, not looking at anything. These are all just very cheap webcams from like 10 years ago, Logitech things. They're HD, but you know, they're not a good bit rate. So the zoom-in camera is the only camera which actually has probably a half decent thing. Bevis, can you enable us to donate with PayPal? Google Pay won't let me donate with PayPal. That's really strange. But Giant, don't worry about donating just yet, my friend. I'm doing an amplifier repair for you, so we can sort that out with the repair bill, don't worry. you're a paying customer. I don't expect you to donate if you're a paying customer. I don't expect anyone to donate anyway, but yeah, if you're a paying customer, then don't worry about that. Well, it's been a pleasure to be around, but I have work tomorrow early. Bye-bye to Bella Mama. Good evening, and I hope work is okay tomorrow for you, my friend. Yeah, it's a bit of a strange one on a Sunday evening, especially if you're in Europe or in the UK. It's pretty late at the moment, so I apologise for the late stream. What time is it? It's 11:30 in the evening here in the UK. If you're over in the States, then this is probably quite a nice time to be watching the stream. It's probably like, what is it, like mid-afternoon, early evening, probably like 5, 6 in the evening or something like that, depending on where you are. I think it's about time for that Hacko, don't you? I think it's about time that I got that Hacko desoldering gun. I think I've saved up enough for that now, actually, guys. So yeah, that should be my next purchase for the workshop. Is a nice Hacko desoldering gun. I'm going to look at that this week. I'm going to look at the which one to get. I'm going to try and get a used one if I can. I always enjoy purchasing used items and used equipment that's been well looked after because it's much better value, and generally, obviously, the decent quality equipment will last. So it's not like you're buying something that's going to die specifically any sooner. The decent kit should really last you for as long as you like, I guess. So buying a used equipment isn't really detrimental in that respect. It's just cheaper. As long as someone hasn't abused it, they'll be fine. Although there is something nice about buying something new, isn't it? Buying something brand new, fresh, that only you've laid your hands on. There is something nice about that. I also like having extra pennies for weekend activities, and I think the weekend activities is probably better than the feeling of having a new Hacko, so I'll probably get a used one. Okay, so that's all the solder out of the pads, out of the holes. So let's get some new drive transistors. This is the first time I've actually had to go to my drawers, I think, in this location, so that's pretty cool. Everything's a little bit further away from me, so the workbench, just behind the workbench, is actually a shelf which happens to be at the same height as the workbench, so which is really nice. It gets everything. Basically, it's made my desk a shit ton deeper, but it just means that everything is a bit further away, like turning the soldering iron on and off, turning the power supply on and off. To get it, everything's like a little bit further away, but that's fine. I can deal with that. Got a lot more workbench area to play with now, so that's a lot nicer for me. So we are looking for PS power supply drive transistors, and I have an absolute ton load of these drive transistors, as I ordered loads of them when I bought these. This is very oversaturated with brightness, isn't it? For some reason I can't change the settings on that camera at the moment. Whenever I go to change the settings, I move the sliders and it doesn't actually change what it looks like, so pretty annoying. Now, it was the PNPs on the outside, wasn't it? I remember this now. PNPs were on the outside of these areas, so we need to go ahead and put the 2SB772s on the outside. That's an Eminem song, isn't it? How would that work? Yeah, that works. B772 goes around the outside. That's a good old school tune. That old school Eminem back in the day. I bet there's somebody here who knows the full lyrics to Without Me. It's one of those songs where, you know, random people just seem to know all the lyrics to. Yeah, so we lost the via to that one, if you saw that. So this one that was incredibly burnt, because it was so badly damaged that the via just wasn't being held in by anything. So the via is now here. The via is now here. So whatever that pin connects to, we're probably going to go ahead and have to make a jumper wire to replenish that connection on top of the board. What are you drinking? Says Aaron. This evening I'm being a good boy. I'm just drinking some sweet and crisp apple juice. It literally says sweet and crisp apple juice. So yeah, it's very, very refreshing. I drank quite a lot on Friday evening. I DJ'd a friend's sister's wedding, which was fantastic. Absolutely wonderful night. But fortunately, because they were very, very good friends of us, they invited us to the wedding meal, the sit-down meal. So we sat down, had all the food and all the wine and desserts, and we watched the speeches and everything. And then I went off to the decks, and they cut the cake, and we did the first dance and got into the disco evening. But obviously, being at the meal, we had free wine, so naturally, yeah, had a fair bit to drink, and that was really nice. I feel like I get better at DJing after I've had a drink, but that's probably a misconception. People say that they feel they get better at everything after they've had a drink, especially driving, which turns out to not be the case. You definitely don't get better at driving after you've had a drink. I beg to differ on that. I'm pretty sure that that's the case. You think you're better at stuff, but you're probably not. So, but people complimented the evening. They said that the music was absolutely on point. So. Yeah, I think probably it was alright. I've no idea if I was any better than I would have been sober. But. We got viewers from Poland, Indiana, Wisconsin. How do you pronounce that one? Wisconsin? Yeah. Slovakia, Alaska, Trinidad and Tobago. Oh crap! So Aaron, interestingly enough, the gentleman that my sister's. Fuck's sake! The guy that my friend's sister married was from Trinidad. So we played soccer music all night. It was wicked. It absolutely was. It went off big time. Fantastic music. And his family are absolutely hilarious. They're so funny. They're really cool guys. So the PNP that I choose to use is the USB772, and the NPN is less important. All it's doing is beefing up the drive wave. It's not as important as the turn-off signal. So we're just going to use some BD139s because they are reliable and cheap. Twerking is a big thing out there in Trinidad and Tobago, isn't it? Like the soccer music and the twerking that's the dance, you know, that's how they dance out there. And not just the young guys, you know, Trinidad and Tobago, like, you know, so I don't know, over here in the UK, like the twerking thing is like all the millennials are doing it, and you know, it's like a very young thing, and all the old fogies haven't got a clue what they're doing, and they're still doing a waltz around the ballroom, you know what I'm saying? But no, in Trinidad and Tobago, like literally the grandparents of the groom were like up on the dance floor, like, and grandma was twerking her ass and all this, you know, it was like mad party atmosphere, and everyone gets involved. So just pushing these drivers back down in now. So we've got the PNPs and the NPNs all loaded up. Let's go ahead and solder these in. I should probably use my small fine tip soldering iron for this, but that's effort. So let's see if we can do it with the large tip. Modbox says, when first tested the amp, every part had power supply voltage on it. Fixed the burnt trace and now speaker terminals at 0 DC, not 14 volts. Ah, good. I actually vaguely remember your question from last time. Yeah, you said, why would an amplifier have the supply voltage everywhere? Like, you put 10 volts or 14 volts into the power terminals, and everywhere you probe has 14 volts in it. What the fuck is going on there? That means you've got a bad ground trace, and then it seems like the Modbox has sorted that now, which is good. Get 0 volts DC ground probe on my amp's ground terminal on the gates. Let's middle leg and supply voltage around 0 volts. Relays in output section also click, and now that fixed group. I'm sorry, that doesn't make sense either. I'm really struggling. Can anybody translate Modbox's comments? I'm really struggling to understand what he's trying to say. I'm not sure if it's a question or if he's just letting me know something there. Do you ever read something, and then and by the time you finish reading it, you're none the wiser to before you started reading in the first place? It's just like you read it and it's like it's gone in, you read it, but you don't even have the faintest idea what any of it said. Yeah, like I said, I should probably be using my small soldering tip for this, but nah, I kind of can't be bothered to change the tip. So this works fine. Just a little bit more fiddly, that's all. Now this is the one that the via fell out of because it was burned too badly. So I think the this is the PNP, so that needs to have the 12 volts on there. So we're going to have to get a 12 volt source and jump over to there. Okay, cool. Looks like we're all good from the bottom of the board at least. Because of these burnt areas. Ah, damn! Now this is the point where I need my cutters, and I lost them. Well, I haven't lost them. I just seem to have misplaced them in clearing the workshop out. So got a bunch of stuff in here. At least I found my good tweezers. I think they're in here. I must have put a bunch of stuff in here. What else we got? We got a Stanley knife. We got Stanley blades. A couple of ICs. Plastic tweezers. No cutters. Damn, that's annoying. Okay, it looks like just because I'm not sure what they'd be. It looks like we're just going to have to go ahead and wiggle these legs off just for a minute. It's going to take longer than necessary, but I can't think where my cutters would be right now because the workshop's all being cleared out. I hate it when that happens. You do a tidy up and then you lose shit. What's your favourite car brand for car speakers? £500 budget. Yeah, it's probably going to be DD or B2 audio. B2 is one of my favourites as well. Massively rate B2 audio. Hiya, Brian P. Another Trinidadian in the house. Wicked stuff. We're actually millennials called Generation Y. You're talking about Generation Z, I'm guessing. If you're between 22 and 37, you're still a millennial. I thought the millennials were... I thought that was the term given to people born after the millennium, i.e. people born in the year 2000 and on. Or is it, are they called millennials because they grew up in after the millennium, like, you know, they were in their teens? So I assumed that it was all the newly turned 18-year-olds that were the millennials. Yes, if you're into communications or marketing, then you have to know all these terms and advertisement and stuff like that. You have to know which target audience you're appealing to, and you give all the different generations and all that names based on when they were born and stuff, and you target different marketing strategies at different audiences. So you can easily say to a client or another team member, you can easily tell them what sort of target audience you're aiming at by just using a code word like Generation X, Y, Z, Millennials, etc. Well, Millennials is like a media thing, it's not really, but yeah. After 2000 is post-millennial. Okay, fair play. On drive board NC, LP, SMPS, is there any specific parts need to be checked if power supply blew up on a Korean amp? I can't think what that board is right now. NC, I don't read the codes on the boards, I just know what they look like by their layout. NC, here we go, this is, so Modbox, this is the exact same board that I'm working on currently. NC, LP, SMPS. No, nothing should be dead on that power supply drive board. The fact that this power supply drive board has survived, and you see the state of this amplifier has survived, then I would pretty much safe to say that most of the time that drive board will be undamaged. Okay, cool. So the drive transistors are now fitted. We do still have a capacitor here, obviously, that blew up in the first place, which is hiding behind this transistor. So we need to find out what that is, but I get the feeling that it's not going to be too important just now. We can probe those pins that remain and see what they do, actually. What I'm more interested in now... Oh, holy crap. Got some exploded capacitors along here as well. That's quite rare for these to go down. Oh, Jesus. Okay, so there's some bipolar capacitors which are along here, and I believe this is part of the bootstrap for... These are the bootstraps for these transformers. And these look like they failed, and it's very, very rare for these to fail. So I believe that these have failed purely from heat. Purely from the heat that these things were kicking out. If you were standing, next to the FET like the capacitor is here, that must have been like putting your head in a bloody oven. And so there's one there that has failed. It looks like it's leaked out from the top, and there's another one on the other side of the board here, over here, which again looks like is proper leaked out from the top. So the bootstrap diode, capacitor there isn't exactly necessary to get the amplifier up and working on a test bench scenario, so I'm probably going to go ahead and cut the legs off of those ones, and they're probably shorted. They're either shorted or they're open. If they're open, then I can leave them in the board. If they're shorted, then I'm going to snap the legs. Okay, well it's showing a 10 ohm resistance, which is going to be the 10 ohm resistor next door to it. So provided that these resistors all show a 10 ohm and don't show a short, then I'm going to leave the Bootstrap capacitors in there just for the time being until I get around to changing those, because they're less important than most of the other stuff on here. The other more important stuff that we need to change now that we have got to the stage with the drive transistors replaced is we need to change the gate resistors. So if you have a look on here, actually this camera is a little dark now. I'm going to go ahead and see if I can brighten the JBC, the zoom in camera up a little bit. Configure video, oh no, it's not that one, where is it? I think it's in filters, color correction, here we go. So maybe I want a bit more brightness, maybe? No, maybe a bit more gamma. Probably, yeah, probably a bit of brightness, bit of gamma. Bit of contrast, maybe. I don't want to make it look too kind of fake. Oh, the contrast works well for this type of thing. Yeah, cranking the contrast helps out a bit, I think. So let me know if that looks any better, guys. So we're looking for, yeah, so these gate resistors, now they all look black and burnt to hell. Now the fact that the drive transistors were so badly damaged, that means that the current has passed through the gate resistors, which most likely means that they're bad or they are damaged. Let's just see, I believe that these are going to be, well, I think they either be 47 or 22s. Most likely they'll stay the same resistance even if they're slightly damaged or blackened. So yeah, we've got a 22 ohms. So these now this amplifier uses some bloody expensive MOSFETs on the power supply. This amplifier uses some IRFP 7 oh no, hang on, these are the 14, where? Crap, where the, they're down here. 7530s, which are these IRFP 7530. These are bloody expensive, so you don't want to screw anything up when you are doing a repair with these. They're very expensive for good reason. They're very, very good. So to get this board up and running, to get the power supply up and running, all we need to do is fit 8 power supply transistors into this board, because this board has, I want this top board camera to be a little bit higher. Like the zoom in camera is zoomed in, but I'd like this one to be a little bit higher, like actually on the top of the board rather than just kind of aiming at the side of it. So we've got 4 power supply transformers here, 1, 2, 3, y 4, and each one needs a pull and a push and a pull FET on it. So therefore we have 4 transformers, so we need 8 FETs. So what I'm going to do is, just to speed things up on the live stream a little bit, is I'm only going to fit, obviously, well, I'm going to fit 8 FETs just for you now, but I'm only going to remove or clean up the pad locations for those 8 FETs I'm going to fit. And once we have made a successful repair, I'll go ahead and fit the rest of them off stream, because it's boring stuff to do that. Yeah, IRFP 1405s are not cheap either. But yeah, the 1405s are not that much more expensive than the 064Ns, which is what the 064N is, like the most popular power supply FET, and has been for many years from Korean and Chinese boards. Yeah, it's used thoroughly throughout a range of different manufacturers. But the 1404 isn't really that much more expensive and is a worthy upgrade. So if you are doing a power supply repair now and the amplifier is, it's a fairly decent amplifier, it's worth something, then yeah, I would say go ahead and upgrade the power supply FETs to 1405s. They're just a fair bit better than the 064Ns now, and they're not that much more expensive. That's 1. So we have 1, 2, I imagine, let's have a look. How many FETs do we have along this side? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that means there'll be 3 push and 3 pull. So we count 1, 2, 3 here. So these are going to be, let's call them push or A. And then the next 3 along, 1, 2, 3, will be the pull or B. So we need 1A and 1B, 1 pull and 1 push. So I'm going to space them out nice and wide so you can get a good view of the A and the B FETs, or the in phase and out of phase, 0 and 180 degree, whatever you want to call it. Hey Bevids, ever experienced an amplifier having over voltage troubles on the power supply rails? The trouble itself occurs when you attach a load to the outputs. The voltage of one rail goes over. That sounds like something that I have seen before, and it's usually down to a shorting output inductor. What happens is the output inductor is shorting, and well, actually there's a few reasons that can cause that. Basically what you're experiencing there is you're experiencing a flyback power supply effect, and that is caused by the output inductor, but it's not always the output inductor's fault. So if there is a drive issue with the amplifier causing one side of output FETs to power differently to the other side, then the effect, because obviously the two different sides of the output MOSFETs, they combine after the output inductors. And so if you have a certain, it has to be a very specific scenario. It's very weird. It's a very weird setup. If the outputs are failing in just the right way, or sending just the right signal to the inductor, then after the inductors, the combination of the drive waves after the inductors combining causes what's called a flyback effect on the inductor, which generates voltage on top of the rail, and is actually how the power supply section works inside of a JL Audio JX1001D. That uses a flyback power supply design, and it works on a similar basis. It uses an inductor and a couple of FETs to produce a kind of flyback effect. But yeah, that effect can occur on an output section if the output FETs are failing and the situation is just right to cause that scenario to happen. So I would be taking an oscilloscope and I'll be checking the drive waves of all of the output FETs and checking that all the drive waves are looking good. None of the FETs are heating up on idle when they're not clamped to the case. And if all the drive waves look good and you can't find anything wrong with any of the drive or any of the FETs are heating up, then I would read the inductance of the output inductors and make sure they're both the same. Make sure none of them are either shorted or have different values to the other one. Now remember I said that the IRFP 7530s are very expensive. Because they're so expensive, I'm not going to fit 8 of those to the board just now. I'm going to put some stanky old IRFP 064Ns, just because they will do everything I need to see whether the power supply section is working properly, and they'll power the output section just right for me to start work on the output section. And then once the amplifier is fully fixed and I can tell there's no other issues with it, then I will go ahead and fit all of the 7530s in the power supply. But we don't need them in there yet. They can wait patiently for their turn. Almost there. Got 2 more of these power supply pad locations to clean up, and then we've got 8 cleaned up FET locations to put our 064 ends on. And the last one over here. Okay, let's just suck the solder from these holes. Then I'm going to read some of the live chat, and then we're going to put some 064 ends on. Greetings from Germany, watching your live stream while being on holidays and wondering what happened to your workshop. It looks different. Yeah, I moved it around. I've had a sort out and it's much tidier in here. I've got a lot more space on the workbench now. It was well overdue. Obviously on the live streams you don't get to see the rest of the workshop. You only get to see what the camera's pointed at, and it makes things look different on camera. But in reality the workshop was almost to the point where I couldn't walk through it. It was that much stuff. So I've had a massive sort out, and it's much nicer now. I've got more space. It's in a different location on the workbench, so yeah, much better. Can you explain what the bootstrap cap thing in resistor does? Yeah, so where you have a transformer or an inductor, or well, if you have any, not necessarily that, if you have any switching, a MOSFET that's doing switching, the bootstrap, capacitor and resistor has something to do with getting rid of any spikes that occur on the output of the FET or from the inductor or the transformer, I believe. The bootstrap circuit is still slightly new territory for me as well. I learned most of the bootstrap stuff from H1 Nicholas on my live streams when we were repairing the Lanzar Opti 7K that had massive headache of problems, and we were searching, we were chasing this fucking annoying issue with the output drive wave being slightly wrong on one bank of FETs, only slightly, and it just caused them to heat up, and it wasn't quite right. We found the issue in the end, and it was nothing to do with the bootstrap circuit, but the weird issue was that it looked like it was the bootstrap circuit causing the issues, and so that's where I learned most of that stuff. But yeah, I think it's to do with dampening spikes and any crap that comes off of the inductor, transformer, or the FET drain, I believe. Oh, I probably need, yeah, I just realised the stream name says JBL, obviously, and we've moved on from that because the JBL had no problems with it whatsoever, so we spent about 10 seconds on the JBL and moved on to something else, so yeah. Yep, this power supply went down big time. These Xenon, these Korean full bridge boards, the power supplies do seem to go down in a big way. The protection isn't very good on these. It doesn't save the power supply from the 3 or 4 boards of these that I've worked on. All of them killed the power supply in a very, very big way. I need to clean this tip a lot more. Actually, this tip is very dirty. I was doing a lot of nasty, janky soldering with a lot of flux the other day, repairing a 21-inch ground zero woofer that was assembled incorrectly by a company. Oh man, I really want to go in on one about this ground zero 21, but I really shouldn't. It would be very unprofessional of me. But oh my god, I cannot believe what I saw. Let's get some alcohol on this this drive circuit area because it looks a bit janky. So I'm just going to spray some 99% isopropyl alcohol. Take my toothbrush, here's my toothbrush. No. Where the hell is my toothbrush? Ah, here it is. Don't forget to connect 12 volts to your number 2 leg of the PNP and NPN. Ah yes, thank you very much. I'm not sure if I would have remembered that. I might have forgotten that if you hadn't said that. So thank you for that reminder. Still looks a bit crappy. To be fair, this toothbrush is pretty old and not very clean, so it's probably going to leave some marks on the board there. So yes, as I was reminded in the live chat, thank you to Seth. Ah, good old Seth. Yeah, we need to make sure that damn. Yeah, that toothbrush is very, very not clean. Look, it's left all a bunch of crap on the board. So let's do that with a towel instead. The problem with doing it with a towel is that obviously the stuff on the board tends to pull and tug on the stuff on the towel. That's why it's better to use a toothbrush, but the toothbrush is very, very filthy. So we probably need to either clean the toothbrush or get a new toothbrush. That's better. Here's a good question. Do those USB box... Hang on. Do those... What the fuck? Where's the live chat gone? Do those USB box PC scopes work the same way as yours? I was looking at purchasing one. I hate those things. They work fine, but I hate them because the refresh rate is so slow. There's a big delay on them. I love my oscilloscope to be absolutely pinpoint reactive and responsive. Like there's no delay between... Because literally, if I'm probing something on the board and I'm measuring a drive wave, and if the second that drive wave goes bad, if it changes shape or if it's bad when the amp powers up, I need to see that instantly, because like my remote pedal, my remote cable is on my foot pedal and I have very quick reactions. So if I see something that's not right, then it takes me less than like a fraction of a second to lift my foot off of the remote pedal and the amplifier turns off. If I have to wait even a quarter of a second or even half a second for my scope to actually show me the wave that it's probing, then that's in that half a second, the amplifier can fail, the output FETs can short, whereas maybe I would have caught it in time if my scope was reactive enough. So the scope needs to be absolutely no delay from reading the probe to displaying it on the screen. That's why I hate digital scopes, well, cheap ones anyway. You can get a digital scope that is cost you a few £1,000s, which will be as responsive as an old analog one. But yeah. So yeah, this Vibe, the 21K bit is a peak figure. This is supposed to do 10.5K, and I believe it does do 10.5K. It does make rated power. Our specialized battery wires for car amplifiers are bullshit. My friend always buys those expensive wires, but as long as I know there's no skin effect happening there, it's just DC with high amperage. Yeah, it's just DC with high amperage. Yeah, but the best cable that I found for installing car amplifiers is welding cable, because welding cable is specifically designed for extremely high current scenarios, and it's very well manufactured because it's designed for industrial use. That's the point. Welding cable is designed for industrial use, where if the cable fails for any reason or is not up to standard, then they got a huge big ass lawsuit coming their way because they burnt down the whole factory and they cost millions of pounds. Whereas with car audio, the car audio cable, there's much less risk factor involved with that. They don't give a shit, and also they mark it up and they make it shit quality and they sell it for a huge price. Buy welding cable. Buy used welding cable, because cable at the end of the day is cable. So if you buy used cable, it's still as good as it was brand new. It doesn't deteriorate unless it's been sitting in water or the copper has been exposed to air, which obviously it's not if it's still in the cable case, you know, as long as the wire's not all exposed. So just cut the ends off and you have some brand new cable, and it hasn't cost you anywhere near as much as it would have done if you'd bought car audio branded cable. Right, so yes, what Seth said, let's make sure that we have that we fix that trace there that broke for the PNP driver. So let's take our multimeter and let's just make sure. So all the PNPs, I think is all the PNPs should have 12 volts on them. So we're going to go ahead and check 12 volts over here. So that's this one over here. So 12 volts should be on all the PNPs. No, sorry, 12 volts should be on the NPNs. Because, yeah, sorry, the NPNs are boosting the drive signal, so they should have 12 volts on them. And the PNPs should have ground on them, because they are grounding the drive wave. So if I now go to ground, yep, so that has ground, that has ground, that has ground. Ah, that's strange. This it does have ground, but only when you push it in a certain way. So that means it's not soldered on the bottom of the board, which means that I might actually be able to get away with soldering that one to the top of the board instead. Which one was that one? That was this one here, Q13, which was the badly damaged one. No, that looks pretty skanky actually on the top of the board. I'm not going to bother trying to solder that to the top. I'm going to go ahead and make a jumper over here around to ground over this side, and we're going to ground it to the one next to it probably. Unless there's a closer ground point. No, that's the closest ground point, I think. So we're going to take a small bit of wire. Now obviously in clearing out the workshop I have put all my small bits of wire away. Now where can I find a nice small bit of wire to use? Maybe I could use some of this crappy desoldering braid. Is that going to be too thick? That might be too thick for this. Or perhaps not. Perhaps not. I don't know, I'm not sure I like it. It's a bit too thick and it's a bit too free. I want a single core. I want just a piece of copper. So let's go ahead and find one of those. BRB. Here we go. Perfect. Just what I'm looking for. Hello. Is it me you're looking for? So this amp has 12 1405s and it looks like 2 FETs per coil. Will it be okay to install just one on each side, or install one per 6 kilowatt? So how many transformers does the amplifier have, Modbox? However many transformers the amplifier has, you need 2 times that number of FETs to make tests whilst you are repairing the amplifier. Yeah, this soldering iron tip is very, very dirty. I really need to clean that up. I'll give it a good old cleaning in this thing, but it doesn't seem to be cleaning it that well. There we go, getting that black crud off of there nicely now, just using a Stanley blade. That's a bit better. It's not perfect, but it's much better. Where's man tweezers? There we go. Let's push it down on the board. Let's get it right at the bottom of there so it's nice and secure. A touch more solder. Damn you! Stay there. There we go. That's the one. Let's bring it over here. Let's get rid of some of that insulation there. Let's bring it round. We don't want to ground the drive signal on this pin next to it, so let's pull away some more of that insulation there. Maybe I can just burn some of that off. Need to clean the iron tip anyway. There we go. Nice. There's 6 transformer windings in power supply section and 2 more in output. Look like 2 FETs spaced in front of each power coil. Do we need 1 in all 6? So if you've got 6 transformers, then you need to put 12 FETs. You need to put you need to put 2 per transformer. So if you should be able to see how they're spaced out, like I said earlier, the transformer will need one push and one pull MOSFET on it, and you can usually see where the push and where the pull is, and they're usually on either side next to each of the transformers. So yeah, if you've got 6 transformers, you need 12 FETs to power the board up. If you're not sure about where they go, just put all the FETs in. Only put the minimum FETs in if you know exactly where they go and if you know how to check. Right, so I only need, I've got 4 transformers, so I only need to put 8 FETs in the board. So let's just double check that we are, now I know the resistors look kind of stanky, but let's just check that they are all about 22 ohms, because that's all that's important to get this checked out and running. So we've got 22 on number 1, so we've got 8 FET locations, so let's check number 2, 22 ohms. The gate resistors do all seem fine. Even though they look pretty bad, I think maybe they just got cooked by the heat and not necessarily by their own current passing. They do all read 22, although some of them do look very bad, so I will go ahead and replace them anyway. But for this test, then I can just use them. That's fine, because they are still reading 22. So we're going to take our drawer here, which is full of 1405s, but at the bottom there'll be some 064Ns somewhere, I imagine. Let's have a look. So here we go, 064N. Let's just make sure it works. Why is there 16 output FETs, 24 N40F versus 12 IRFP 1405s? Isn't it usually an even number of each? Depends on the rate. Now it depends on the ratings, absolutely. The output FETs are more passing high voltage and low current, whereas the power supply is passing high current, lower voltage. So where you've got higher currents, you need more surface area of thing to pass the current, silicon in this case being a MOSFET. So therefore you need more MOSFETs because there's a higher current being passed in the power supply section than in the output section. So that's why. Right, so that's 1064N. Let's find another one. That's 2 and 3, 4. I need 4 more. 5, 6, 7. One more 064N, and there we go. There's our 8. I wonder if I do actually have any more that are the same batch. I want to try and keep them all the same batch if I can. Just, you don't really need to for this quick test, but I've got some 315p batch there. There's a 315p batch. That is a random one. That's a 710. That's a 706. That's close enough. That's a 710. Any more random ones over here? This is a 710. It's not that important for this quick test. That's a 715p, so that's kind of close to that one. It's a 710. I've got loads of 710s. Maybe I'll just try and use the 710s where I can. These look like a more modern purchase. 614. Yeah, okay, there we go. So that's 1, 2, 3, 4, 5, 6, 7, 8. I've got 8 of these relatively modern looking FETs here. So let's put those ones in the board for testing purposes. Okay, cool. Now, before we put the FETs in, let's just check that the drive waves are making their way safely to the gates. So let's put our power supply leads back in the board temporarily. So it's good just to check these things along the way. Alright, and let's get the scope fired up. So power on, there we go, 10.3 volts and 0 amps after the caps have charged. So let's give the thing remote power and let's make sure that we have a sexy looking drive wave on all of these 8 gate pads that we're going to be using. Yeah, okay, looks good. So we're drawing 0 amps, as you can see, or 0.1. Now that 0.1 of an amp is just the relays. And you can see that the 0.1 of an amp only kicked in when the relay kicked in. So yep, that looks good. Yep. Okay, cool, that's gonna be fine. Now, interestingly, what did that capacitor have on it? Let's go ahead and let's have a look at that. So the capacitor that exploded is just back here behind this. You can't see even the zoom in cam because of the way the angle is. I'm going to probe the cap that exploded. On one leg we've got nothing. On the other leg we've got 5 volts. So all it is, all that cap was just a smoothing capacitor for a 5 volt rail. Let's see, was that to do with the relay? No, that's probably the 5 volt rails. It's probably the VCC for something. Not too sure without tracing back where the leads go. So that capacitor is not too important to be in the board by the looks of things. It's just a smoothing cap for some 5 volt rail. So we don't need to load that into the board just yet. We can continue our testing without it for the time being. What's the board number of cap you're looking at? It's number C. What's that? Looks like it's CE27, CE27. Yeah, you got some caps of CC. It's CE being C electrolyte, electrolytic. Sorry, electrolytic capacitor. So CE, yeah, CE27. This other cap we've got is CE38. Yeah, it's a CE27. Alright, let's put some 064Ns on then. I'm going to make sure these FETs work because these are obviously FETs that I have used to test with before or taken from a donor amp. So before I go ahead and solder them in, just going to make sure they actually work, which they make sure they're not shorted. So I'm not going to solder them in fully. What I'm going to do is what I always do, and it was pointless to suck the holes actually, is I'm just going to solder the FET to the top of the pad on each of these. If I can get the zoom in cam up on where I'm going to be soldering to, you can see what I do. So rather than putting the FET in the holes like this and soldering from the bottom of the board, which makes it more difficult to take the FET out, because these are only going to be in the board temporarily, all we have to do is lay some solder balls on top of the pads here like so, and attach the legs perpendicular to the board. Because no current is going to be passing through these, we're not going to be running an audio signal to any speakers. All we are going to be doing is charging the rail capacitors and seeing what the output drive looks like. So we don't need, this is why we're able to use 8 very low current FETs compared to the originals, and we only need to solder them to the top of the board like this. Okay, so this FET that I almost put in the board is actually dead, so good job I'm checking these as I go. This one is also dead, perhaps. Or am I just testing them wrong? Oh no, I'm stupid ass. I'm too used to testing these things with my transistor tester that I forgot that actually that is how they work. When you test them with a multimeter, you get a 23 ohm resistance when you after you've probed the gate. You charge the gate up with a multimeter and then you probe the resistance between the drain and source, kind of, and it gives you a low ohm reading. I do need to lift this camera. I want this camera like higher probably like up a bit so you can actually see what's going on the board. At the moment it's like kind of pointing at like an angle, which I don't like that much. So I'm going to have a play with that at some point, get the angle a bit better on this camera. I'd quite like it to be similar to the zoom cam, but a more like overview kind of, rather than a zoom in from the top. I want it to be like a top board overview kind of camera. Well, I could just stick the good old head cam. Yeah, maybe I'll do that. Maybe I'll stick the head cam on. I haven't used that yet this evening. So let's get the head cam. I think the wire is long enough now, yeah? So, where are we? There we go. Head cam! Woohoo! The head cam sometimes doesn't like focusing, so just gonna have to. The head cam is actually working, I think, really quite nicely in this format with the workbench where it is now. I don't know why. I don't know, something about the angle has changed or something. But I think the head cam is working pretty nicely. It looks quite good on my screen. I know that it's only a really low quality webcam, and I could probably get something a lot better quality going forward. And like maybe not GoPro, because GoPros don't work by USB Live, I don't think. But something similar to that, something like a small action cam style thing that doesn't really need to focus too much. Okay, there we go. So that's the FETs in the board now. So we have 8 IRFP064Ns, which are more than enough to get this thing up and running. Now, before we can actually apply any power to this board, this power supply section is now going to be sending big high voltage to the output section. And we haven't actually checked anything on the output section yet, so we don't even know if there's any shorted MOSFETs. So the last thing we want to do is to be sending high voltage to a shorted output section. So let's go ahead and check first of all that we don't have any shorts on the output section. So to do that, let's go ahead and, oh dear, yes we do have some shorts. So this one, you see, although it's a short, it's not a direct short, it reads 24 ohms. So that suggests that there is a short in this bank, but it's not this FET, so this one can stay. Let's move on to the next one. That one is reading a direct short, so that one's going to be dead, because that is a direct short. We're not even reading through the gate resistor, which is what the 24 ohms was before, so that one can be good, can go. Next one. Now you see now, there is no longer a short scenario on this bank. This one that was reading 24 ohms before is now reading a 532 on continuity. So this was the single dead FET in this bank of, what is it? It's a bank of bank of 3. No. Bank of, hang on a minute, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Yeah, sorry, yes, bank of 3. 1, 2, 3 here. 1, 2, 3 here. So this next bank, bank here also has a shorted FET in it by the looks of it, because we have 24 ohms on there. This middle one here is a dead short, so let's get rid of that one. Okay, and this one doesn't have a short on it either, so it looks like it was just that middle one. Let's go ahead to the other side of the board and see what the situation is over there. Okay, that looks good. That looks good. That bank looks okay. And this bank looks okay. So it looks like the output section only had 2 dead, like straight up shorted FETs in it. Some of the FETs that remain in here could still be damaged and they could no longer be a MOSFET anymore, but they are not a direct short circuit. So that is safe enough for me to warrant powering the board up like this. If any of these FETs are damaged and they are not shorted but they are no longer a MOSFET, they're just a bunch of diodes or something, then they will probably explode when I power the power supply up. So this could be fun. I think we'll probably be okay though. So the reason that we're powering it up now is we're checking the rest of the output FETs, and we're checking the output drive circuit wasn't damaged by those 2 FETs killing themselves. The output drive circuit is buffered by some drive transistors as well. If we take a look at the board again with my zoom in cab, you can see these are obviously the transistors that buffer the power supply, and these are the transistors that buffer the output section. So similarly, we have a board here which has the drive ICs, in this case a IRS 21844S, a pair of them, which is interesting because they're half bridge chips and you have a bridge chip and a bridge board in the middle. And these emit drive waves which get buffered by these set of transistors, which are PNP and NPN, and then that goes to the gates of these MOSFETs here. So let's go ahead and power her up then. Let's take it to, what view do I want? I'm not liking this view this evening. This is the view that I should be using really for this. I don't know, something about, I'm not really liking, I don't know if it's not very good quality or something's not right with this camera angle this evening. But anyway, let's just use that one because it's got the scope in the corner and everything anyway. So let's go ahead and turn the power supply on. Hopefully this doesn't short out. Hopefully the FETs are good in there. Okay, so I think we have either a solder bridge or something going on, because there appears to be a direct short across the power supply. So either one of the FETs that I fitted was actually shorted, because I didn't check the last few ones I fitted, or we have, oh no, there's no direct short across there. So maybe I have made a solder bridge between the gate and the 12 volt. Now there we go, well, there's a short across there, so I might have made a solder bridge there. That's a 22 ohm resistance there. 22. Now the 22 ohm, that's actually, 22 ohms is is the 22 ohms is the gate resistor, so that's probably not the FET that's dead there. There's probably some issue elsewhere. Probably one of these other FETs is shorted or something. No? No? Okay, well there must be something wrong here. So it's between... Ah, hang on a minute, now it's gone. No, it hasn't. Right, 22 ohms. 22. 22. 22. Yeah, I'm not too sure where the short is then, because it's all reading 22 ohms. So usually if it was reading 22 ohms, then on these it means that the short is somewhere else, because we're reading the short through the gate resistor. I wonder if one of the drivers just shorted out for some weird reason. Because if we're reading a 22 ohm short, then that means that we're reading it through the gate resistor. So if we go after the gate resistor, let's just find the short again. Where was the short? Short was over this side, between the gate and it was here. Right, so this is where the short is, 22 ohms. So if we go after the gate resistor, it's actually a dead short. So that means that one of the drivers must have just shorted out for some weird reason. Yeah, looks like we just lost one of the NPN drivers. That's very strange. Where would that have happened? Okay, so yeah, this NPN driver appears to have shorted. That's very strange. I wonder if that's some remaining residue on the board there. I'll have a look and see what... No, there's nothing in that section of the board. There's nothing in that section of the board. EXO Control, so how's it going, my man? Good to see you on the stream. I hope you're doing well. This is a pretty in-depth, interesting repair. Very curious stuff going on here. Missed some of the interesting stuff earlier. What time is it over there at the moment, where you are? We're at about 12:30 in the evening at the moment. Just enjoying some good old bevids. Cheers for tuning in, EXO. I've not seen you on the live streams before, so that's really cool. I remember when we met in the at Modified Nationals. You mentioned about being curious about amplifier repair and how these things work, and maybe being able to do some repairs or upgrade yourself. So if you want any help or anything, or if you have any questions, man, just shoot me a message, man. Let me know. Although to be honest, I'm sure you're probably far too busy with the various other projects you have going on. So let's get rid of this NPN here, because this one appears to have killed itself. That's either due to the leaked electrolytes from the capacitor that died when this amplifier went down, or something else. Tacit? How do you say your name? Sorry, buddy. Hey Sam, just joined. Any update on the big black amp that had the weird short to the case from your live stream the other day? The big black amp that had the weird short to the case. What was that one? Can you remember the brand of that one? I remember we were looking at a Steg amplifier that was having some strange issues. What was the one that had a short to case? I'm gonna have to hold this in my face because I can't get this transistor out here. Just gonna cook up the 3 pins here, give it a good old pull and fucking come straight out like. go. Now we can go ahead and cook it up from the other side and get this one out. This is slightly annoying because what I don't want to do is I don't really want to snap the legs here because I want to find out exactly what happened. And snapping the legs will mean that I can't read the transistor after I've taken it out. I wonder if it does need that capacitor. Okay, that one's gone. We lost that one. Now remember I said earlier, we looked at the top of the board over here. Let's take my zoom in camera. Let's zoom in on this top of the board again, right? Now this is curious, this is interesting. I wonder if anyone knows what the situation is here with this, right? Let's take a look at this area here. Right, so this is the drive circuit, okay? So we have the PNP on the end here, which is going to be turning the FET off. And we have the NPN here, which is turning the FET on. Now remember I said, when I first took a look at this, I looked at this trace here and it looked like that there was meant to be continuity between pin number 2 of the NPN and pin number 2 of the PNP. Because it looks like that the trace here actually snapped itself around about this mark here. It looks like the overcurrent caused this trace to snap. However, that wouldn't make any sense because that would mean that we would have 12 volts on both the PNP and the NPN, which we know can't be the case because the PNP needs to have ground on pin number 2 in order to get rid of the drive wave once the 494 has turned it off. So that's a curious one. Maybe that is actually not a cut, not a break as such, but that's just where the trace ends. And it just looks like a cut because it's been damaged by the heat. So let's just have a make sure. So that has continuity there, which is correct. We're meant to have continuity to the drive wave here, continuity to the drive, to the exit drive there. Okay, so the pads are all making the correct continuity where they should be there. So that's okay. Let's going to flip the board over. I'm just going to make sure all the rest of them are on the bottom as well. So we should have continuity. Let's have a look. Which one failed? This one. Ah, that's interesting. The short circuit wasn't actually on the transistor. Look. This is really quite rare. The transistor itself is fine. The short circuit is somewhere else on the board because we still have the short even after we've removed the transistor. So it's not the transistor that's the problem. How strange. I wonder what it is. That's really weird. And we still have the short on the actual board itself, over by the FETs. That's a really interesting one. I wonder what this is going to be. Okay, I'm going to clean up that pad so we can solder in there again in a minute. I'm going to put the drive transistor back in place because it's fine. There's nothing wrong with it. The short is somewhere else on the board. So where could that be? Let's have a look. We're going to have to. There's a few things we can do here to find the short. Obviously, we'll try the classic method of just probing stuff until we find something that's short that shouldn't be. Usually, shorted components are semiconductors, so there'll be a diode or a small transistor or something like that that will be shorted out. Capacitors can also go short. Resistors, when they die, they usually go open. So it's unlikely to be a resistor that's the problem. It's likely to either be a small capacitor, a diode, or a small transistor that has actually gone short there. Got some stream lag. Shouldn't have any stream lag. Apologies. Seems good my end. I've got 0. Oh wow, this is very rare. We've got 0 drop frames. That's pretty crazy. Do you like Machine Gun Kelly? Sometimes. So let's put this NPN back in the board because that's fine. No problem there, sir. And let's go and continue our search. Let's solder that back in and continue our search for whatever the hell is shorted. And it's interesting because I don't think that short wasn't there before. Because if that short was there, would the thing have powered up on without the FETs? I'm not sure if it would have done. The legs on the blown cap aren't touching, are they? No. The legs on the cap are far apart, and they are on a 5-volt rail, which the drive transistor area itself doesn't use 5 volts. The TL494 will use 5 volts. The protection circuit will use 5 volts. There's probably something to do with that. Alright, let's just make sure I did a fair job on that. Make sure that's soldered in nicely. Make sure there's no continuity between that pin and that pin. Yep, looking good. Okay, cool. Okay, so donde está our short? So let's turn the board over to have a look at the components so we can identify where the semiconductor components are that are likely to be shorted. And there's a couple of diodes around this area, so I wonder what looks better, the head cam or the zooming cam has some shadows going on. That doesn't look too great. Let's go ahead and try the head cam. Yeah, the head cam probably is better for this. So let's just check D17 first. That's the first semiconductor IC. Nope, that one's fine. Let's check Q. What have we got? Q32 still has a whole bunch of this crap from the exploded capacitor around it. So let's remove that. I might get my toothbrush back up in there. Where's my toothbrush? Here it is. Okay. There's 2 more transistors here and a couple of diodes. So let's check the diodes from the top of the board. A couple of diodes over here, DZ3 and DZ2, which are going to be Zener diodes. So let's see if they're shorted. Nope. So we are looking for something that is a direct short here. Okay, let's flip the board over and let's check all those pads for those other transistors. The small one and the 2 larger ones. So we got the larger one, got one of them here. That's fine. One of them here, that's fine, and the small one is over here. That reads fine as well. But we still have our short circuit on this area. Very, very strange. Okay, so what does this? It's going to be difficult actually to know where this area goes because. So this obviously has 12 volts on it. This is an NPN, so this has 12 volts on it, and this leg out here, I believe, goes to the gate. So that means that we're going to be sending 12 volts to the MOSFET gate, which is not a good idea at all. So it's going to be difficult really for me to say let's power the board up and see what gets hot, because we're going to be turning the FETs on indefinitely, which is not a good idea. So okay, it's possible then that the short is around this area. It's possible that there's some solder bridge that is connecting one of the gate resistors over here on the non-gate side, so on the driver side, which is going to be this side, to a 12 volt source. So I'm going to go ahead and just do a real good check, a real good scratch around make sure that nothing is touching these gate resistors to the 12 volt power input. Just go with that one over there. I think I know what might be causing the issue. So you see how these MOSFETs are laying down on the board here, right? Well, you've got these very, very small traces that come from the drive section of the board. And I reckon that maybe one of these legs is laying on the trace that has been damaged and therefore is shorting out. So what I'm going to do is we're going to check for the short. I'm going to lift all the FETs up like this. I'm going to lift them up off the board, and I reckon that will probably sort it out. I reckon there's a very slightly damaged like front of trace, and I reckon that's probably what it is. Let's check. And would you look at that? Oh no! Ah, bugger. Okay, it's still there. Okay, let's just to prove that theory, see if that is the case, let's try removing the FETs from the ones that are shorting. There's we've got that one, so it's only the B side FETs. That one. It's going to be... Is it any of these ones? I think it's only the ones on this side. Yeah, so let's remove those two. Removing these two should hopefully get rid of the issue. So let's have a look on the board. Let's make sure it's not shorted to the trace that runs along the board. That's what it looked like it might have been. Okay, so that's those two FETs removed. So let's see, is the short still there? Okay, the short is still there. Curious. Okay. Let's remove all of the FETs on this side, just in case it's this one. Because it could be this one, because it could still be shorting the trace that goes to the other FET, to the positive. Aha! I think I found it. And it was what I thought. Is the short there anymore? Okay, no, the short has disappeared, right? And I don't know if I'm going to be able to get down close enough here to show you this, right? But that issue was caused by something as small as... Oh, bugger. Maybe if I use the zoom in cam, you can see it. It is just here. I'm going to zoom in a bit more. Come right if I can reach. Okay, let's get something to point with. So the issue was that this tiny trace, which goes right next to this pad, you see how it's lost some of its coating, some of its insulation, right? And where I had the FET laying across the board like this, it's actually shorted this here. This little bit of trace is exposed. It shorted it to this leg, and because that charged the gate, it was shorting it essentially to this one. So that tiny little bit of missing insulation there could have caused a lot of random headaches if I didn't think to look for that. So in order to get around that, I'm going to have to fit this FET with the legs bent upwards temporarily, and then obviously when the FETs are fitted properly, then that won't be an issue, provided we don't make a solder bridge to that trace. But that shouldn't be a problem, you know. That's just that's where the amplifier failed and it lost the coating on the trace. That's really interesting. Do you think a 22 ohm gate resistor are good enough if at 22.3? 22.3 is the 0.3 is probably just your multimeter's test lead resistance. So if you touch the two leads of your multimeters together, it probably reads about 0.3, 0.4, 0.6, something like that. So yeah, it's probably fine. Yeah, 0.3 tolerance is fine. The gate resistor is just there to prevent ringing along the signal line. So yeah, it's not got to be exactly, they've not all got to be like down to the exact 0.1 of an ohm the same. As long as they are similar enough to not cause the drive wave to be different on each of the FETs, then you're fine. So let's put these FETs back. It was only that one that had the damaged trace there on the drive signal path, so we don't need to bend them up on all of them, just that one. It's funny how it looked like it was the driver that was shorted, didn't it? Because, you know, like it really looked like the driver was short, and you'd never know. The only way to know for sure is by removing that driver, and the short was still there on the board. Okay, so that should have sorted that now, and I should now be able to put some power to the board. It shouldn't draw excessive current, so let's just check before we put the power on that there are no more shorts. There we go, that's not a short, that's the capacitors charging. That looking good, yep, looking good. And the other side was all perfect and fine anyway. Alright, I think we're ready. Let's put the power in. B+. I always wondered why it was called B+, but then obviously I realised that B stands for battery. Battery plus, battery positive. Do you know Steve Mead, and do you like him? I don't know him at all. I've watched a few of his videos. I've not watched that many of his videos, to be honest. You know, people have differing opinions of him, but I don't think I've watched enough of his stuff, or I've never spoken to him, so I can't really gauge, you know, his character based on that. So I feel like it wouldn't be fair to give an opinion based on my lack of experience knowing him. Right, so let's turn the supply on, and hopefully it charges the caps and then the current stops. Ta-da! That's exactly what I wanted to see. Okay, cool. So there's no more short circuits and no more leaking shit anywhere. So let's take our oscilloscope probe. Now this time when we power the board up, this is where it does get a bit scary, because we are charging the main rail capacitors, so we'll get a very high voltage on the output section, and therefore we will see the drive waves, and if any of the FETs are not happy, they may explode. So I'm going to turn the input voltage right down to 9.5 volts, and that has the effect of lowering the rail voltage, which makes it a little bit safer to work on and gives a bit of extra time in case there's any component that's failing. It doesn't quite blow up in such a bad way. Speaking of Steve Mead, explain on today's video how to make cheap man's distortion detector. I've done that video already. You know I've done that video. Have you seen that one? You must have seen that video. That video's got tons of views. There's even a video that where the guys test out my theory on their video and it works. It's pretty cool. Okay, so let's check this thing out. So back of the power supply FET, obviously we have our 9.7 now volts. It fluctuates a little bit, this power supply. So let's go ahead, and I'm just going to pulse the remote very slightly. Like this, just going to pulse it just a little bit. Just to build the rail voltage enough to see what's going on. So on the rail, oh Jesus, that didn't build the rail by very much, did it? I only built the positive rail by 2 volts. And the negative rail also by 2 volts. How much current am I letting pass? Oh, that'll be because I'm only letting 1.2 amps pass. Okay, let's turn that up to 5 amps. Let's let a little bit more current pass. Let's build the rail a little bit higher. So again, we're going to pulse the power supply like so. If we were to probe the output inductors, we can see that a great big square wave starts to appear. Well, I say great big, maybe a bigger square wave, and it starts to charge the rails. We're now at 20 volts on the rails. So what I'm going to go ahead and do is I'm going to go ahead and check the low side and high side output FETs. So on the board here we have 3 low side FETs and 3 high side FETs. On the other side of the board, we'll have 3 low side FETs and 3 high side FETs. As I say in every repair video, the low side FET should have on pins 1 and 3 the negative rail. So you see here, negative rail, and pin number 2 should have absolutely nothing. If you see, even if you see like 2, I'd say there shouldn't be any more than like 2 or 3 volts. Sometimes there's a little bit of residual voltage on this leg, number 2, the drain, but there should be pretty much absolutely nothing on pin number 2. If there is something on pin number 2, then you have a problem with the drive or you have a leaking MOSFET. So that's fine. Let's check this side. They're all good. Now let's check the high side. So on the high side is the opposite situation. On 1 and 3 we should have absolutely nothing, and on number 2 we should have positive rail, which we do. It's sinking down pretty fast because we've got some pretty low value drain resistors on the caps. So that is looking healthy. So let's check the other side. Let's just pulse the power supply a little bit more to build that rail a little bit higher again. So yeah, we've got negative 15 volts, and on number 2 we've got 0, 15, and on the high side we've got, so this is all looking good so far. So that is the last check that I do before I let the thing turn on fully. So now we're going to go ahead and do the scary part. We're going to give it more current than that. We're going to give it about 8 amps, and we're going to crank it up a tiny bit to nearer to 10 volts. And I'm going to let the amplifier come on fully, and I'm going to stick my oscilloscope probe on the, what am I going to do? I'm probably going to stick the oscilloscope probe on the low side FET. I'm going to put it on the low side FET drain, so the middle pin that doesn't have anything on it. And by probing the middle pin that doesn't have anything on it, I will instantly see the drive wave when it generates. So I'm going to turn my scope up to 50 volt divide so we can see the drive wave nice and clear when it happens. And I'm going to turn the amplifier on, let it pulse, and you'll see the thing draw current. So let's go. Oops, my remote cable has fallen out, so that's why it's not doing anything. Let's put that back in. Try again. That's better. Okay, are we going to see a drive wave, or is it going to explode? Okay. So at the moment, it looks like it's going into protection. We're getting to 75 volts, and then it goes into protection. So let's just see whether it might be going into protection because it's not getting enough current, but it also could be going into protection because of some other reason. So let's see. First of all, I'm going to check, are any of the power supply FETs getting hot? Because if the power supply isn't repaired fully or properly, then that might be causing it to go into protect. So let's just do a check first. Now all the power supply FETs are dead stone cold, so it's not that. The output FETs, we do still have all the correct voltages everywhere that we should. So rather than checking the low side drain, let's check the low side gate. And let's see what happens there as we turn the amplifier on. So it should pulse down. Yeah, we get to 81. So yeah, we get to like 81 volts, and then the thing goes into protect. So maybe this amplifier wants more than 9.8 volts in order to come on. It might have a low voltage protection circuit. So let's go ahead and turn that up to, I don't want quite as high as 11. I want about 10.5. Okay, let's try that once more and let's see what happens. Oh, there we go. So we did have some switching wave there. It only appeared for a fraction of a second, and it stopped before I took my foot off of the remote pedal, so it went into protection itself. That could have been due to current draw. So I'm going to give it a tiny bit more current. I'm going to give it, oh yeah, 8 amps is fair bit of current for this amplifier. So so that was, this one worked fine. This FET worked fine. So I'm going to go ahead and move my probe now to a different, I'm going to move it to the other low side and check that one. Yep, okay, that one comes on, but once again, as you can see the drive wave there, it sort of it sinks down and then the amplifier turns off. So I'm just going to do that again and watch my power supply, see what happens. Yeah, so it doesn't seem to draw excessive current. It's only drawing about 2 amps when that comes to life. protection light is kind of flickering, so it's not very happy about something. So it doesn't seem like it's getting enough current to turn on or something. The power supply FETs are still stone cold, so that doesn't appear to be the issue. I'm going to check the heat on the back of the output FETs and see if any of those are getting hot or anything like that. No, they're all stone cold, so nothing's getting hot. It doesn't appear like anything is drawing current or anything like that. So I'm going to turn the voltage up a little bit more. So we're at 10 volts now. I'm going to go probably up to about 10.8 if I can get there on my supply without it jumping around like crazy like it always does. Actually, screw it. Let's do... Yeah, that's about right. So 11.7. And let's see whether the amplifier stays on any longer now. Okay, there we go. So it just needed a bit more voltage on there. So these amplifiers don't like low voltage. So yeah, we have a very stable output drive wave there on the low side drain. That looks pretty good. I'm going to go ahead and zoom in on my scope, and we're going to look at the low side drive wave. So I'm going to go ahead and turn it to AC coupling and knock my scope cam out of the way at the same time. And go from 50 volt divide to 5 volt divide, I think. And let's turn her on again. Let's see that low side drive wave. Ooh, doesn't look that great. This is not a particularly good looking low side drive, but that's not necessarily the sign of a faulty amplifier. So as long as both of these low side drive waves look the same, I'd say that that is just how this is. Yeah, they look the same. So these FETs that this amplifier uses are very hard to drive. They have an insanely high input capacitance, which means that the thing that's driving them is getting hit back in the face by all this back EMF and capacitance and shit on the FET. So that's why the low side drive wave looks so terrible. That's just how it is because these FETs are so bad, hard to drive. And because of that, these FETs don't like working in parallel very much. And I'll show you exactly what I mean in a minute, actually. This amp isn't too bad. So these amplifiers, from what I've seen, do have a design flaw with the drive circuit. So that low side drive wave looked pretty bad. And it's either due to that bad low side drive, or it's due to the FETs that this amp uses. They are seriously fussy with being run in parallel with each other. They don't like running alongside a FET, even from the same batch, the same factory batch, that is even the slightest bit different in terms of specification. So the FETs that this amplifier is running with now are clearly all fine. If they were even the slightest bit damaged, then they will have exploded by now, that length of drive that they were running just now. So these are all good FETs that survived whatever caused the amplifier to fail. If we take our thermal imaging camera now and we have a look, every time I press home, my live chat jumps up to the bloody top. If we take our thermal imaging camera, and so this is the case not just with this amplifier, but every single one of these boards that I've worked on, even ones of these that didn't have any issue with the output section in the first place. So I've worked on one of these boards that had some issue with the power supply section, some vibration damage, fixed power supply, and then obviously I just checked the output section was fine, and it was. But these amplifiers have this problem from the factory, so it's not a problem with the output section that caused this, like a failure. It's just something there's a design flaw. So I'm going to go ahead and turn the amplifier on once again. I'm going to clamp my my probe here to the high side drive. I think would be a good option to clamp to, so we can see what's going on in the scope there. And I'm going to show you on the thermal imaging camera. Not sure how well this makes it out really. What the situation is here with the FETs and which ones are getting hot. So let's go ahead and fire the amplifier up again. I'm going to need to change my scope setting actually so it actually looks okay, because that's too zoomed in at the minute. Okay, there we go. This amplifier's come on. We're drawing 3.7 amps, so this is fine. Okay, so let's take a look on our thermal imaging camera then. What gets hot on the board? We are going to have the pull down resistors getting warm for the rail caps. That's fine. Now if we have a look at the output MOSFETs, they should all be staying stone cold. Okay, so let's have a look. What do we have? We've got a few bits over here. So we've got some area over here getting warm. Now the reason that these get hot is because these are voltage regulators. That is normal. That's not a fault. Not a problem that these get hot. Let's move over to this side of the board. Now here we have one MOSFET here reaching a tasty cookie. No, it's not that high. It's 34.5 degrees and climbing. So this one high side MOSFET is reaching 35 degrees. All the others are staying absolutely stone cold so far on that side, and on this side we have the FETs are also staying stone cold. We have a glowing area there, which is the pull down resistor. That's not a FET. And let's just go over. Yeah, so all the FETs on this side are staying stone cold, but we have one cheeky FET over here which is running hot, and it's now running up to it's now up to 41.7, 42 and climbing. So what's happening here is not a fault with the drive, it's not a fault with the amplifier, it's just that that FET is a very slightly different spec, maybe has a different VT or a different CG than the one in parallel with it. Now because I removed the sensor FET, this bank only has these two FETs in parallel, so it's this FET and this FET. So whatever's going on, this FET isn't happy being run with this one for some reason, or it's not quite being driven properly, but the drive is exactly the same between these two FETs. So I would say it's probably a VT issue. So there's no problem, there's no fault as such with the amplifier. It's just that, you know, these FETs, they're very, very fussy. So what I'm going to do is, because of this, I've got a whole bunch of spare FETs of these in my drawers over here, and it's labeled the 300 volt parts here. So what I'm going to have to do is I'm just going to have to go through and try different FETs, different ones of these in that location until I find one that runs cold, because even when you test them on the transistor tester, they can read like almost identical, very similar, but still they don't like being run in parallel with each other. So it's obviously a very specific, very small, minor difference there that means that they don't like being run in parallel. So, but saying that, on a good note, this amplifier appears to be fully repaired in terms of like main issues preventing it from working. So obviously I've still got some work to do on this. We've got to fit the rest of the correct power supply FETs, which are the IRFP 7530 PBF, very expensive power supply FETs, but very good. And we've got to replace the capacitor that was on the 5 volt rail in the power supply drive section, and we've got to replace the two blown MOSFETs that were in the output section and match them well so that they all run nice and cold. But yeah, once that's finished, and there's one other thing as well. I do need to replace the Bootstrap capacitors in the power supply section because they had leaked from being overheated. So I'll need to work out what those are, read the readings on those, order some from RS Components and replace those. But yeah, that's very simple stuff. I can see the clear road ahead as to what to do with this amplifier. It works, it comes on, we have output switch. That's the repair done. That's the main bulk of the repair out of the way. The rest of it is just reassembly, really, fixing the parts that need fixing, and yeah, pretty good. You're awesome because you made a distortion detector and didn't charge over 100 USD. Yeah, I didn't make it. I didn't come up with that idea. I mean, I came up with that idea like myself, but like what I'm saying is that isn't a new idea. Other people have used that method long before me, so I just thought it up myself, but I'm not the first person to think that and to come up with that. Do you recommend the PC PSU car amp combo? Nah, man, just get a proper home amplifier. It's much easier for so many reasons. It's a very inefficient way of getting amplifier power by doing the PC power supply car amp combo. I've done it before, and I wouldn't recommend it. Just get yourself a nice home or PA amplifier that's designed to run on mains power. Much better. It's easier, less drama, less issues, more efficient. DC audio 10K. Ah, did you find the fault? Yes, I did, and I fixed the fault with the DC 10K. Yes, yeah, there. That one was all good. Yeah, DC 10K was all fixed. Nah, that was what was causing the. There was a short to the case. What was causing the short to the case? I think it was a hole or a something on the thermal pad that was causing the short to the case on that one. Okay, cool. Gonna leave it there this evening. It's just a Sunday night, and I've been getting some good sleep lately, so I want to try and keep that up. So about getting on for 1:30 in the morning here. So I'm gonna leave the repair at that. I'm gonna read a few more stuff in the live chat before I go though. So how do you guys like the new setup? Does the new setup work better? So yeah, I got that camera view. I still don't really like this view. It doesn't really show much. Like all you've got is you've just got like a weird side-on view of the amplifier. I would much rather give you a more top-down view, which is this one, which is obviously my zoom-in cam. But I hate having to keep jumping up and to change the zoom on there. Like I could zoom out of this to give you a more overview, like that. But I hate having to keep standing up and changing the zoom. What would be really cool is if I took the camera apart, and obviously that zoomer slider is just a fancy potentiometer, pretty much. So if I could desolder that from the board in the camera and reroute it on a long wire down to by the bench, so then I could zoom in and out with the zoom in cam from my bench. Like with a switch down here, that would be freaking cool. Maybe I'll do that. That's that's going to be a bit of a hassle project, but that would make my life so much easier, and it would allow me to literally I'd be saying, oh yes, look, and here, and we've got this issue, blah blah blah, with this drive circuit here. I'd literally just be able to go to the side of my desk here, and then the camera would just go like this automatically. Zoop. That'd be really cool. It'd be very nice and handy for me to be able to do that. Thank you, Jesse. That's kind of you. Oh, head cam is awesome. I'm glad you guys like the head cam. I'm not too, because obviously I'm watching it on a very small screen, so I can't check the quality of the head cam. But I'm glad that it works. I need some more foot pedals, because my foot pedals have only got 3 pedals. So I've got like wide view, top board, zoom in, and then the rest of the views are just shortcuts on my keyboard for head cam, scope, and Google Chrome. Pretty dark out there. See, it's night time. Can you guys see that? No, you can't see that. It's pretty dark out there. It is a little bit more organized. Yeah, it definitely is. Do you have any schematics for these amps so we can follow you during the repair? That's a good question. I usually dismiss the schematics things like basically I never use schematics when I repair these, but I've never thought about the fact that actually having the schematic on hand for you guys would make it easier for you to follow the repair. So maybe I'll try and get I've never bothered trying to get schematics for these before because I don't need them to repair them. But thinking about it, it would be useful. Like you guys would probably find it useful having the schematic there to look at whilst I am working on it, so you can see exactly the areas that I am working on and why they've been affected and stuff like that. So yeah, things that I've still got to do. I'm going to wire up this second screen that I've got, so it makes it easier to be making orders online and doing stuff on the computer whilst I'm live streaming. I'm also going to put some little Digital Designs T-line bookshelf speakers that I've got. They're actually the tops to my old T-line surround sound setup from my old videos. They had their rotels in them and the two tweeters. Well, I blocked off the tweeter holes and I've just put some DD speakers in them. They sound phenomenal. They're bodged to fuck. The tweeters are duct taped to the top of the box because obviously the tweeters are closed back enclosure, so the tweeter doesn't need to be in a box. It can just be mounted as close to the mid-range driver as possible for phasing and stuff, and a good stereo image. But they sound incredible. These things, they look like shit obviously, but they sound amazing. And I do want to put those in here, so they're probably going to go. I'm probably going to put these bookshelf speakers. Probably one will go on top of the scope, and obviously that will raise that screen up higher, and the other speaker will either go in between the power supply and the soldering iron, but then that will make my soldering iron a bit too high. So maybe I'll just have to put it on top of the soldering iron. It will have to go on top of the handle, so it might be at a weird angle, but fuck it, I don't care. I don't care what it looks like, as long as it sounds great. And I'll be running that off a Digital Designs DSi1 processor, so it'll all be processed properly. And then I'll probably have that running on, not too sure what amplifier I'll run that on yet. I do have a spare Technics that needs a bit of maintenance, so maybe I'll do some maintenance on the Technics. I've got an SUV 60, so I'll do some maintenance on that. Use that for the mid bass, for the woofers, and then the tweeters can go on something else, some small Class AB. Make a little shelf over the side. Yeah, that's a good idea. Yeah, maybe I'll make a. No, making a shelf is effort. I ain't got time for that. I'll just whack it on there. One side outputs higher voltage than the other. Most likely, the issue in that amplifier there is the preamplifier, all the crossover, the switches and stuff like that. Especially the balance potentiometer, they get corroded and they don't pass enough signal. So probably the reason you've got more voltage on one side than the other is actually because you have like faulty switches and knobs on the preamp part at the front of the amplifier. So I would take some contact cleaner, just clean the shit out of all that, turn all the knobs and switches loads of times, clean them all out, get them all really nice and clean, and then that should sort it out. Right, I'm going to leave it there for this evening, guys. Thank you for joining me on my first live stream in this setup. Hope you enjoyed the amplifier repair. JBL was nice and easy, nothing wrong with that one. And yeah, we've got to the point now where this Vibe amplifier is fully fixed. We just need to fit the remainder of the parts, and then she'll be good to go. So thank you very much for joining, and I shall see you in the next stream.